Ta-da! So now you can't say anything about anybody now because
Uh-oh.
we're live. So as I say every time, we're gonna wait until people are like, "Hey, we see you and we hear you," and
All
then
right.
once they start saying yes, good. Oh yeah, can you guys hear us? Personally, I blame the squirrels. John writes that in every one of my videos. All good. Can you guys hear Bradley?
Hello? This is Brad from Savage Fabrication.
Yes, sir. Mucho good. Yep. Yeah, everybody can hear everything. So, well, I guess I'll introduce you, and then you can introduce yourself better than me. But this is Bradley from. You want like Brad or Bradley, or you don't care?
I don't care. My-
Savage
Yeah.
Fabrication and Diesel, should I say? You do a lot of Diesel stuff.
Yeah, mainly our main focus is in the diesel aftermarket just because there's a big hole there. There's a lot of opportunity to make parts to help other people out.
And then the other one is where are you guys located, just for fun?
Central California, dead center.
Oh wow.
So yeah, in the valley.
And then if you want to go ahead and explain, like summarize what you do and how long you've done it.
Well, mainly welding and fabrication. Been doing that. Oh, got out of high school 2009. Went to school for chemical engineering. I'm terrible at English, so I finished all the math and science side of things, but couldn't get the past the English courses. So switched over to welding, blueprint reading, and structural work. From there, got my certs and got in a local job shop. Learned agricultural fabrication and repair there. So heavy ag work, the big D9s, D11s with the big 9 foot shank rippers and big mobile grinders where they grind up stuff for all the animals and everything. Those are fun. And then you don't really get paid a whole lot at a job shop. So a local place started making pleasure offshore fishing boats. So they're not for commercial use. They're just big offshore fishing boats for people that have a lot of money, mainly farmers in the area. So that's where I learned my stainless and aluminum work, was building all the fancy railings and trim pieces and dash panels, fuel tanks. We even did called a gyro mount. They got these big gyros that spin down in the bottom of these things real fast, and they balance the boat out so it stays flat as it's going across the waves. The boat will actually hardly rock at all.
Huh, I never knew that. I always wondered why some are more stable than others, but that makes sense to have a giant weighted gyroscope in there.
Yeah, yeah. So this one was probably maybe the size of your fireplace back there, but they got in the big container ships. They have full rooms that are these giant gyros for those things. The owner of that place stopped paying all the employees, so that went out of business, and I used what I learned there to start doing just general mobile fabrication work.
He just kept opening the doors and just stopped paying everybody, or
Yeah,
what?
yeah. Everybody, no one was getting paychecks, and only certain people were getting paychecks.
So strange.
Um,
That's the
yeah,
first
so
time I
everybody
heard of
got
that, but
yeah. He just kind of like disappeared out of nowhere. So we kind of repoed a lot of our stuff and moved on. But I had all this tooling and just a basic skill base to do fabrication and repair. So started doing that. And on the side, we were working on diesel trucks, just repair head gaskets, upgrade parts,
good old
exhaust
six
systems.
liters.
Yeah, actually, well, we never got to work on the power strokes too much, but I do have a friend that moved out of state finally. But he literally, bread and butter, he has done everything with power stroke motors. So he serviced fleets and he was never out of money.
So you just carried
From
over all those skills into starting your own fabrication?
Yep, yes sir. From there, we started just kind of fixing turbochargers every so often. We get to repair them. That turned into doing it more often, starting to play with them quite a bit. And after thinking that I could build them, actually early on, it was probably about 6, 7 years ago, started building like our own turbochargers, kind of upgrades for people. And I thought that more air equaled more power, and by more air I meant more compressor wheel. So we were leaving the turbine sides alone and just putting big old compressors in these turbochargers, and it was just cranking EGTs up and making them smoke more. But I didn't know any better. Probably 3 to 4 years after that is when I figured out that bigger compressor doesn't mean more air. It means more capacity on the compressor side, and where we actually need to look is the turbine side, and that's where we started getting into doing turbine upgrades. There's a turbocharger that Holset made that has a really cool internal gate design that you only see on the ETR and EFR turbos from Borg and Garrett. And we could get access to this thing for $300 because you can get them off of wrecked trucks or people that upgrade. And that had upgrades, so we would take that, retrofit it backwards onto these old trucks, but that was still kind of expensive. You have to buy a turbo, upgrade the turbo, and then pay us to fabricate the turbo to your setup. One of the days I was looking at one and I was like, we could probably machine this thing to fit an older turbocharger. And one of my friends was like, go for it. So we did. And from there, that was the beginning of called the HX Super 9, which is, I call it the superhero turbo because every turbo needs a superhero. And that thing's been great for us for the last 2 years. We can't keep them on the shelf.
So it's similar to like a disco potato of diesels?
Yeah, it's a turbocharger that's built out of 3 different turbos.
Huh. And is it like a one of those one size fits all that's good for almost everybody, so that's why it's popular?
Yeah, and we did something that spools faster than everything else out there. Not intentionally. I just had a grudge against S300 turbos because on turbo diesels, mainly the inline 6 motors, they're not that great of a turbocharger. I wanted one for probably 12 years. I finally got my hands on one. I got it and got it in my truck, did everything that the internet says I should do, and it was terrible. You know, everybody's like, you drive around it, and I was like, oh. Guess if everybody's tolerating this, one person eventually has to not tolerate it and say there's got to be something better, and that's kind of where we started cutting turbos up and sticking different parts together and created what we got now. So it spools faster, it has better EGT control, and will make more power than any of those models will.
Oh. Is it how is the cost on that? Is it the same or better than like comparable upgrades?
Yeah, we run, it depends on where you get like a gated S300 from, but for the turbo diesel, like a fully machined S300 with an internal gate usually will run between 1400 to 1600, and we're right at 12 to 1300 depending on kind of what you want.
Well, that's good. Well, the other that was quite the lead up there. I'm like, man, yeah. Did I ask questions already? There's so much info. Well, the other ones I like to ask are sloppy mechanics questions, and then we go right to viewer stuff. So how did you first hear of sloppy mechanics?
Probably my friend Spencer Turner. He has a 5.3 Chevy, and he's like, you got to listen to this when you're on Power and Speed. He's like, you got to listen to this episode of panel stuff. And he's always bugging me all the time. He's like, dude, he's like, we got to put turbos on my truck because it's cheap and it's easy. And I was just like, oh, you're killing me. He's like, you're going to, like, he has a 4L60. It's like, you're going to burn that thing up.
Oh, yeah, in a day.
Yeah. Well, I was like, you're going to burn it up. It's going to, your fuel mileage it'll be fun, but it's going to do everything probably that for a daily drive around truck is not going to kind of be what you want it to do. Plus, we got smog in California and all that fun stuff. So.
Oh, yeah. Disaster.
Taking it off on and off every year is going to suck. But I was like, but he's always hyped you up like over and over and over and over and over and over and over.
Poor guy.
And then, yeah. But finally, I was watching, you just started doing the live stuff, and the big one was you had Joe Simpson on, and I've been following Joe Simpson for a while, big fan of his fab work. So I was like, I'm going to listen in on this, and I like that he has the hub dynos. Hub dynos are cool. So listening to what he had to say about fabrication and dynoing and stuff like that, how he handles his business was really interesting. And from there, I've been kind of watching the lives every time.
So that's when I heard we were talking smack on diesels, and you're like, I can answer this.
Yeah. Well, I've been doing that to everybody. Holdner, you, and some of the other live ones. They kind of sometimes they'll bring up diesels, which is warranted, the coal rollers, the O rollers, as we like to call them. But I was like, hey, we can, I can tell you kind of why it does it and how to correct it. And also a lot of the SI spark ignition guys kind of think that diesels are slow. But what is happening right now is they're actually going a lot faster than what a lot of people think. There's three main ones, pro mod diesels, that have already set a crap load of rules. And I was just talking to another guy, Cole Stang, on Instagram.
I know who that is.
Yeah, and he's more into the racing stuff, X275 and all these things. Like, there's all these rules for diesels and weight limits. I was like, yeah, but there's only 3 pro mod diesels that are actually competitively fast, and they've already have a ton of rules for them. So they're already trying to kind of put, I wouldn't say a kibosh on it, but they are making it probably more difficult than it needs to be. But the No Mercy and No Prep guys are really throwing a fit over the 4x4 pro mods. They get they're more consistent on traction, and they can run a 5.5/8, a 5.5/8 to a 5.08, no problem.
So they allowed to run 4 like Mickey Pros?
Mm-hmm.
Wow.
Yep.
Okay, yeah, that's a little bit of a game changer there.
Well, they used to be dirty, slow, and the 60-foot in the diesel world has always kind of been a problem. But with recent understanding and technology that's out there, the 60-foots on a lot of these 4-wheel drive trucks are getting down on a prep track. They're probably getting into the 120 area, 120 to 140, and then on a non-prep, they could pull a 160 on a no prep, 2.0, 160, 60-foot.
That's really good, obviously, for no prep.
Yeah. And they're just consistent. If you were to look at it from a consistency factor, horsepower versus consistency, a lot of times when it's no prep racing, consistency wins.
Yeah, you just have to not blitz them and smack into the other person for no prep racing.
Yeah. Yep.
All right. And then we'll go into the questions here. We got a lot of them actually, so
what turbo do I need for my stuff?
Yeah, exactly. So it says, what do I want to ask first? I'd like to ask him his opinion on modern diesel trucks, specifically tuning with emissions intact or deleting. EPA crackdowns seem to have more people offering and requesting emissions intact tunes. But what are the pros and cons for emissions and deleting and everything else?
The cons are the EPA. The pros, I would say it's kind of the same thing as looking at anything that anybody else builds, even spark ignition wise. They're not making. I said it's not commonplace, at least, to see 1,000 horsepower stuff that's emissions intact that a regular person can build. To put a full emission system that would support 1,000 real horsepower on a spark ignition engine for the normal person's probably out of their price range, and it's similar for the diesel world. That stuff it's really band-aided real bad. The problem is kind of the diesel fuel itself. To get the diesel to make less soot, it'll produce more NOx. If you want to produce less NOx, it'll make more soot. So it turns into what do you want the after treatment system to take care of primarily? Usually NOx is easier to take care of than soot. It doesn't plug up, NOx the gas doesn't plug up filters like soot does. So it's
and also it doesn't
easier
scare people. So even if it's burning clean, but it just blows smoke, people are not about it. It doesn't care. They don't care if the tailpipe is clean. If it's sooting, then it's the most dirty thing in the world. So.
Yeah, well, I was just talking to a friend about the other day about meth. You'll see this on. I actually heard someone else talking about too. Methanol cars, when they start to get real rich, will actually produce enough acetylene particles that you see. So that's what it is. It's acetylene particles. So a lot of us are familiar with a cutting torch. So if you start your cutting torch up with low oxygen, it tends to create soot particles.
It'll
so
make
diesel
those floaties all of a sudden the room has got those floaties everywhere. I'm familiar with that.
Yep, same thing. So a diesel creates a much larger acetylene soot particle, where with a homogeneous gasoline setup, you have nano acetylene particles. And then the same, I was looking into it the other day just to try and keep my facts straight. A direct injected gasoline also creates a greater amount of these nanoparticles. So you see it with methanol. Once you get enough fuel in there to where you get enough rich zones in that combustion chamber, so if it's running really rich off the hit on the line and stuff like that, you'll see that brown plume, and that's actually the same thing that comes out of the diesel trucks. It's just a lot finer than what comes out. It is flammable. I mean, on the methanol car, probably not. But on a diesel, if the smoke is thick enough, you can take a blowtorch to it and it will catch on fire.
Was that like, I call it the chimney mode? Some diesels just have fire coming out of the stack.
Yeah, so that's called the candle. We call it lighting the candle, and you can use the candle to tune. That can kind of give you an idea of where the combustion event's occurring.
So is it super late, similar to like an anti-lag? It's like negative amount and it's burning past the valve and everything else?
Correct. Yeah, it's a lot of heat still. Get into like diesel's fuel burn speed is extremely slow. So when the injection timing is either too late or the fuel quantity injected is so big that it takes too long for the fuel quantity to pull heat out of the compression event to light off. So then it lights off late. You'll get the flame out. So if you're ever watching like super stock tractors and the pro modified tractors and truck pulling, usually on the line when they're bringing the RPMs up, you'll actually start to see a cone. And then once the RPMs come up enough and the boost comes up, so cylinder temperature is right and compression speed, so it creates cylinder heat as well, is right, that cone will go away. And then if it stays, they'll usually put more timing in it.
Huh.
Yeah, so you'll see the cone come up, and then it's kind of when they're lighting everything up because everything's cold. They're dumping a lot of fuel in, but they don't got a lot of boost pressure yet or piston speed to create compression heat. So a lot of times you'll get that cone, and then once they get to full fuel, the cone will go out. If you have a cone on a diesel truck at wide open throttle, you're probably going to melt something.
That's awesome.
Unless it's nitrous fed, that's a kind of a whole other little deal. But
oh, okay.
you get.
What is?
So I guess we can answer that one to finish it up though too real quick. Is the way that they're doing emissions on the diesels is still not in their favor, just because they create these large soot particles. What they're doing right now is they're putting at least for the Cummins engines, they have a throttle blade in because we don't create vacuum with most diesels. So the way they're creating vacuum with turbo diesels, they're putting a throttle blade in there, so they can create a vacuum on the intake side to pull EGR out of the exhaust, because burn turbos, drive tends to be below boost. So if drive's below boost, you're not going to really get EGR into the intake side. So what they're using is a throttle blade to create a vacuum on, or at least try to balance the pressures out so they can pull EGR out of the exhaust side in. And they're using that for two things. One, it preheat the inlet air temperature. This helps with emissions. It doesn't help with performance typically, but it does help with emissions. And then two, they can control how much CO2 is going back into the chamber. And you can use CO2 to control the flame propagation speed or the burn speed of the flame in the cylinder, and you can control NOx and soot formation that way as well. If it's too fast, you create NOx and less soot, and if it's too slow, you create less NOx and more soot.
Same thing. My buddy Cameron asked the question. He goes, what do you think about a compound for a truck used just for normal towing? He has a 2004 and a half Ram 3500. Would it give some more grunt when it's locked up in overdrive going up hills? Also, is it necessary to intercool between chargers or just after the second one?
Second question. Intercooling between stages really isn't extremely necessary for the everyday person. You'll still get a density ratio number that would be, say, above the single turbo would be. Kind of what happens with I tell people with compounds, there's only two reasons to have them. One, you have such a big turbocharger that you need a small one to get it lit. Or three. Two, the amount of pressure you need because you're limited on engine RPM. If you are limited on engine RPM because of your class or whatever, and the only way to get the density ratio up because you can't run more engine speed and more boost pressure. So it's eventually going to get to a point where a single is not going to survive at 90 pounds of boost sustained. And then the next thing would be for towing. If you're in a condition where the engine speed is so low, or at a condition where all the boost you get with the single, so if you only get 20 pounds of boost and you want 40 pounds of boost, there's no magic turbo, like single turbo, that's just going to give you more pressure without costing you in engine RPM. So like the choke point, if we look at it like a cylinder head flow choke point, so you have to make the turbo so small to make
multiples because it solves all those issues.
Yeah. So you can put compounds on, and then you get, I call it getting like a little bit under 2-1, because you're using one part exhaust to get 2 whirly boys to go. Instead of trying to use one part exhaust for one charger, and then trying to use, you got to basically increase the heat energy through fuel injection to get more boost out of it. Where if you put 2 turbos on, you'll get exhaust that goes through one, gets wasted, and then it'll get gone through the next one, and it'll spin it up. And as long as you size them right, you'll do okay. We try to get, if you had 40 pounds of boost on the manifold, then we'd probably be wanting around 40 pounds of boost out of called the atmospheric. We want to try and keep them ratioed together to where they're working well. One thing that if you do calculate compounds, the density ratio you get after you calculate everything out, you get a lot more bang for your buck if you can get more pressure out of the atmospheric, the big guy, than out of the manifold unit. Cold is working off a new atmosphere. So if you calculate what it thinks it's doing with the new atmosphere, it's actually a lot less than what a lot of people say. And this took a long time for me to figure out, is that, say if you had 30 pounds of boost from the big turbo, and then you had 30 pounds of boost from the small turbo, so you got 60 pounds of boost on the gauge, a lot of people would say that they're working equally hard, and in reality they aren't. The pressure ratios, even though one's 30 and one's 30 getting 60, they aren't the same pressure ratio. They're actually different.
Oh, that is weird. The other, so I guess what he's getting at then, aside from twins, triple turbos, etc., is how would he has it has stock turbo and everything. It just has a tune in it and whatever else. I'm assuming he's like, how do I get better bottom end or towing power on hills and whatnot, and not just like a drag race turbo? And is there a direct swap on that's better than stock but doesn't, kind of like a Goldilocks turbo for a stock style Cummins?
Yeah, so we build one for those trucks. Then the big thing is I kind of like the truck to maybe dyno around probably 390 to 420 wheel before going to this charger. But what happens is we actually tend to lose a little bit of boost at a cruising state or say a loaded state, but we'll pick up enough engine volumetric efficiency by bumping up the turbine side that will actually gain torque output. So it's like a balance.
Bottom end.
Yeah, and it's a really fine line. Like I call it walking a tightrope versus it losing both too much, or it might not gain enough VE for the amount of boost lost, and we got to balance those two out. So we kind of look at it from a horsepower standpoint and engine RPM. And then the other thing too I would ask is, are your expectations realistic of what the turbocharger can do? Some people that I talk to, they want more boost at 1500 RPMs, and that's kind of an unrealistic number without going to compounds. And then the next thing that'll happen is they'll take out the head gasket, and transmissions and clutches and all kinds of other stuff get really expensive really fast because you're starting to build a lot of cylinder pressure down there. So a lot of times, some of the times is we'll just tell them, hey, instead of trying to pull the grade at 1500, downshift and lock it up and pull it at 18 to 2200. If they're already doing that, but they don't have EGT issues, then we'll just tell them put more fuel in. Put fuel in until you have an EGT issue, because it'll start to gain an EGT before it'll smoke. And then if they're at the point where there is an EGT issue, that's where we start looking at turbochargers.
Oh, okay. So maybe just a custom tune would make the world of difference for that. Okay.
Yeah.
And then there's other I like how you said manage expectations, because that's what I always say to people: realistic goals and managed expectations. I say that like every time I'm going to tune stuff, but that's probably most important. People are missing that. So yeah, it makes sense where also there's just diesel bros that are like, I want 100 pounds on my boost gauge. I don't care about anything. I want my boost gauge to wrap around because it doesn't matter how fast, slow, or if it burns things. I just want to, I want a compressor gauge that pins.
Because when I was watching that video, someone went drag racing for the first time with one of our turbochargers, and for their very first time on the track with a diesel setup that they don't really understand, they did they did an okay pass. Definitely a lot of tuning. It needs more fuel. It needs a lot of things. But they got back, and they're like, we found out that it had a pretty good boost leak in it, but the gauge was still pinned. And as a turbo builder, that makes you cringe, because if you have a boost leak, depending on how bad it is,
Yeah, overspeed.
for the turbo to overcompensate for that is Holdner says, what is it, mechanical sympathy. So that's what I kind of have, like, mechanical sympathy for my turbochargers that we build. I'm like, man, if you have a boost leak, this thing might be doing 160, 190,000 RPMs, and you're getting really close to the point where it just tears the exducer apart.
Well, that's why more and more I've seen more and more turbos are having a speed sensor. Like a lot of the VS turbos have the speed sensor eyeball, and then I know people are building in safeties too, like boost pressure versus speed. And if it's out of control, it limps stuff, or it turns off the. A lot of those people are running like CO2 boost control. It'll just revert to gate and turn it off and everything else.
Yep.
I'd love to look at data like that. I don't get to look at EGT, or I just started looking at coolant pressure and exhaust pressure and a bunch of other stuff this last year, just trying to learn more about it. Obviously, I hit a point where I know enough about what I have, and now I want to know more. I want to fill my brain with other stupid things. So I'd love to look at something.
I was just talking to it.
Oh, go.
Oh, sorry.
No. I will talk too much, so it's your turn.
I was just talking to a customer today. It was the same thing. They kind of asked if because I said something, they're like, yeah, you like it how like Gail Banks does it. And I was like, well, there's something being rude. There's some things that Gail Banks has said that aren't correct, and there's a lot of things that he said that are correct, and that happens with a lot of people. So I kind of like I try to be the person that kind of sits back, reads every paper I can, reads every book I can, listens to every podcast and YouTube video that I can, and I pull out things that I find line up with what I either see on the street or on the dyno that make things make sense, that I can either do the math equations for, and it adds up to what we see on the dyno, or I can do the math equations and repeat it. And a lot of the times I'll do them and be like, I got it. And maybe a week or two later, or a month later, something will happen and be like, no, that's wrong. Yeah. And to be able to say that you were wrong and then go look for the next answer as to why you were wrong is something that I think has helped us do really well in this market.
Of course, that's what I love. I love being proved wrong and learning stuff. So, and there's plenty of times, I think, when I have a bunch of tuners on, I'm going to ask them, like, a possibly dangerous question is, what did you used to do before that you learned is wrong and you don't do anymore? Or when was your last failure? And I know a bunch of people that might be like, I've never had a failure, or I'm perfect. And those are the people that are full of shit. Because
I always tell people I've done everything, or I shouldn't say I've done everything wrong, but most of the data that we have is because I personally did it wrong. And I had to figure out why it's not doing what it's supposed to be doing. And it usually comes full circle that I made an incorrect component purchase based off of something that was popular on the internet, but wasn't actually what would actually happen on the chassis dyno or down the track.
Yeah, similar to where for a while people are like, you're dumb, you should do this. And I go, okay. I called it Internet Week in my other video, and I'm like, what should I do? You're all experts, what should I do? And I do it and be like, nope, you are clueless as me, so let's go to the next person. And I would just break stuff until one of us figured it out, but I gave everybody the opportunity to tell me exactly what to do. There's a good one. What did I have? I had a question come in and then fleeting immediately, so maybe I'll think of it later. Something got brought up in my head. All right, well, we'll ask another question. I'll see if I can bring it back. This is something I want to know for sure, and I think I know the answer to. Oh, I know. I'm going to write it down then. There's a YouTube channel I want to ask about diesels. I just wrote it down here. Joey says, are there any standalone diesel tuning options on the market?
So this is where there's a big problem, is that there is only one that I know personally. There is only one standalone controller currently available, and it's made by Bosch, and it runs you right around, I think just for the controller and harness, I don't know how much else it comes with, is like 10 to 12 grand. So it makes it very hard right now for people to get into this. So what most people are doing is they just pull the harness and ECMs out of the wrecked vehicle, and then they swap the engine in, and they use a current tuner like EFI, HP tuner, stuff like that to control the factory ECU. But there is currently no offerings that I know of other than Bosch, and it's pretty spendy. Is it really nice? Yeah, it's like Motec for diesels. I was like, but I've been talking to some people. I'm like, there's a huge market if anybody wants to get into it for standalone stuff for the diesels. I don't know if the EPA gets in the way of this occurring, rules and such with diesel engines, but there's a big market there.
Yeah, they're making it harder to flag things as off-road only too. I've seen even the companies that sell headers and stuff like that are getting pressured to not do it because of even though it says not for road use. So someone had donated S14 Sean. Thanks for sending in $5. So whenever people pay, I ask their question as soon as I can.
Yeah.
It's part of the payment, how it works. So how do you tune fuel on diesels? I've always heard EGT is the equivalent of a wideband on a diesel. Is this true? Thanks.
Very close to it. I kind of tell people you can tune a diesel just like you tune a two-stroke. If you have any experience, like kind of messing with two-strokes, you can kind of tell what's going on based off of the smoke opacity of the two-stroke. So you can do the same thing with a diesel and an EGT gauge, other than it is really helpful to have a dyno or at least a full set of gauges, EGT, boost pressure, engine speed, compressor outlet temperature, and then post intercooler temperature. I kind of like to have all three of those at least to kind of get an idea what's going on, because there's different conditions that'll happen out the exhaust that won't make a whole lot of sense. But if you have all these gauges, they will. So usually what the EGT gauge picks up on a diesel, because it burns so slow in the chamber, is that if you have too much called duration, so for you guys it would be duty cycle, for us we call it duration. So when the duration gets really long, what happens a lot of times is the injection vent will actually start to chase the piston down the bore. And when that happens, stuff tends to get really hot because we need the burn. I always tell people, regardless of what it is, if it's a piston engine, it's 15 degrees after top dead center to 45 degrees after top dead center. Cylinder pressure needs to be right there. If it's not right there, then it's not making the power that it should make. So to kind of look at that with diesels, you can see that when the injection event gets to be really long or really late, they will get really hot and they will make crap for torque and horsepower. And you can see that on the EGT gauge. So when the duration's too long or the injection event's too late, they'll smoke, and the EGTs they'll start to go through the roof. So we'll start to add timing in, as long as it's not a duration issue or a duty cycle issue. We'll start to add timing into the system. And as we add timing, EGTs will come down and it'll start to get cleaner. And we do that until we don't see a gain. And then we usually go back 2 degrees. We usually do it in 2 to 4 degree changes. Once we find that it flatlines, we go back 2 degrees, and that's where we leave it.
So what do you see on an average? Because I have like an average amount on a Turbo LS car, like a delta. If it stops gaining a percentage or a delta, I quit and go back also, like you said. So what do you see? Like, what's a typical gain to the tire, if that's what you use, a chassis dyno, per degree, or something you would look for?
I wouldn't. It's kind of hard just because of the way diesel makes power. All the fuels make power off of the fuel, but the way that diesel makes power, it doesn't have a brake specific that it has to stay in, and it doesn't have a AFR that has to stay in. So it kind of throws a lot of the stuff for a loop as far as what you might see. And there's a couple different ways to manipulate the flame speed in a diesel. So if those conditions are being met, then you'll see more or less gains a minute. So usually I like to see gains of at least maybe 15 to 20 horsepower minimum. If it's any less than that, then that's within air, I'd say, on the dyno. And I don't think that there's anything more to be had if we're just making these small bumps.
Yeah. So you guys aren't looking at like we would look at an air fuel and a certain amount of timing. So you guys are doing the whole, not that, but something similar to that, but not that at all. So you're changing like the timing, injection event, and then how much you're injecting.
Yeah, so there's 2 sides to it. Um, what was I gonna, and everything's different too because everybody the way you probably maybe understand my frustration with the way we have our system set up for injectors. Injectors, fueling, it's very confusing if you were coming from the spark ignition side of things to the diesel world. The way that you pick an injector is extremely confusing. So what I
It
usually tell
is.
people,
That's one of my questions down farther below, but yeah.
you can get
Hopefully
there.
my eyes don't glaze over while you start going over it. But like
Are you
on
good?
3, try to give us the bottom answer that's simple, and then try to work your way up until we're all
Yeah.
like, okay, overwhelmed.
No problem.
Oh, did we lose him? Lost him a little bit. Oh, now you're back.
Okay.
We
You
lost
good?
you for a second there. Go ahead.
Okay. Oh, no, I was just want to make sure he got his question answered properly.
Oh, no, the fuel, the
Yeah, the
fuel one.
timing, yeah, the fuel EGT one.
Yeah, yeah. Okay, so
Oh.
you can completely tune off EGT a
Mhm.
little bit, but you need to know everything else.
Yeah, because there's two things that'll make EGT hot. Driving the engine way past its peak torque zone will make EGTs high. Um, Too much duration will make EGTs high. So driving past the torque zone too far makes EGTs high because the CO2 buildup in the chamber goes up. Basically, VE falls down and the VE is replaced with CO2. It slows down the flame speed and the mixing rate. So we'll get high EGTs. And actually, you can have a clean, you can go past peak torque and be smoke free, and you can hit 2,000 degrees on the EGTs. We've done it.
It's
They
crazy
will make,
how it just takes conventional gasoline tuning is a walk in the park, it seems like, compared to diesel. And that's part of what I guess the mystery is people just break them and they have no clue and they're like, well, they're just crappy.
yeah. Um, So that you can. Another thing is that's if you ask way too much of the turbine side of the turbocharger, you will also end up with high EGT and be smoke free. And then there's the last one where the duration's long. There's to be a lot of heat in the chamber when the exhaust valve opens, and EGT will be high and it'll be dirty.
That's crazy. It's I'd love to do like a engine dyno one day and try to soak as much as I learn better in person most of the time. So
Yeah, one of the kind of the fun. Someone was asking on one of the channels about. They wanted Richard to dyno engine in reverse. Like they asked him what would happen if you dynoed it backwards. So if you started up at 9,000 RPMs and then use the dyno to pull it down and get a reverse graph,
yeah, I remember him asking about that.
that's how they dyno tractor pull engines. And
Oh,
they'll
they
pick
load
up,
them until they die down.
yeah, they'll bring them all the way up to 6,000 RPMs and then they'll apply the load and yank them all the way down to 4.
Well, that makes sense because that's what they're doing. They're starting out high and then they're just pulling
Mm-hmm.
enough weight to drag the motor down to stop.
Yep. And what was cool about that is because of the inertia of the rotating assembly, they would generally pick up around 300 horsepower doing a reverse pull. So an upsweep versus a downsweep.
Yeah.
And you'll actually tune a diesel two different ways depending on what you're doing. If you're doing upsweeps or downsweeps, the tuning's different.
That's funny because that it seems like a dumb question, but that's actually how they tune some diesels.
Mm-hmm.
100%. That's funny. I learned something. Oh, a guy here just commented that semi trucks are dynoed that way too. I guess they pull them down because I would assume the whole time you're accelerating with a semi truck, you're getting slowed down because of wind resistance and weight and everything else.
Mm-hmm. And because the diesel burns really long, that's where I've been trying to find, like, I've been reading a lot of papers about it. And most of the people say that diesels make more torque than horsepower down low because of cylinder pressure, which is, I do believe, partially true. But I think a lot of the torque also comes from this slow flame burn. So it doesn't make a lot of pressure all at once, but it just continues to push on the piston, even when the piston is trying to slow down. There's a pressure front on the other side of it, but it's still pushing against it. And I think a lot of the torque, especially under a load, say going up a grade, comes from that slow burn speed. If it burned fast, I don't think we would make the torque that we did.
Well, here's another one. Well, this is just like a, you know, what do you think post, but I'll just ask it. So Ben Brenner says, in your opinion, is the future of performance diesel tuning as bleak as it's beginning to appear?
Um, I'd almost say is that go that to me almost kind of like that maybe the whole industry has to be a little bit careful. Um, I think with diesel stuff, the problem is getting into it can be a little bit hard, and to get into it at an affordable level, you have to kind of break EPA's rules to, in a sense, to do so, unless you want to buy a Bosch standalone. So it is a little bit hard to get into it, but the people that are doing it at a competitive level are all running diesels that do burn clean, and they're running. Right now the fastest time fire pump diesel with their Pro mod has done a 395 or a 398 on a
I was going to ask about
315.
them. Sorry to interject there. That's what I wrote at the bottom. I've been watching a lot of their videos with a dyno and that short guy that they always pick on him, the dyno operator. And I was going to ask you if you could play through, like, I mean, we'll get to that later, but unless you think it's a good subject, people have a bunch of questions. But that stuff, I think I got to warm up to that because he's like microseconds, something, something, something. And I'm like, I wish they would do. What'd be cool is I should ask them is to do like a soup to nuts video that says like the basic. And I'd love for someone like, you ever hear of Engineering Explained on YouTube? One of those guys, or infographics, show how a diesel, like do a graphic of how it's burning. Because you can explain it, but I have to like see it to know. I'll be like, oh. So yeah.
Yeah. Now, same thing. I kind of, because my friends all give me crap because I always tell people, it's like mentally I can see what's happening.
You can see it all, but none of us can. Yeah.
Yeah. I was like, because it's so fast. I always tell people it's so fast that we like, if we were to be able to see it, we wouldn't even know what to do about it. So you have to slow everything. You have to always tell people you got to think like the engine. So the engine obviously cares about it because when we make a change, our power changes. So you got to kind of think like the engine, slow everything down to really slow and kind of get an idea what's going on. But that is hard to convey. That's why we kind of started our own channel to kind of get depictions and drawings and
I didn't even know you have one. I got to go sub right now. What is it?
It's just Savage Fabrication. No one had stolen it yet, so.
Oh yeah, you got to get in there and register on everything. Where?
Yeah.
Dang, where are we? 165?
Yeah.
Oh man, guys,
Rally.
stomp on this quick. Let me copy it quick and dump it into the chat. Yeah, so you started doing informational everything else. I'm very interested in that.
I was like, I have all this information I've gathered, and it's starting to cost a lot of time on the phone to go over all of this, because I do like to talk about it and go over it and make sure that.
But not 65 times with every person that calls.
Correct. So I was like, it's probably smart to finally kind of get this out on the internet and say, hey, thank you for buying a product. Now, we can make the conversation a little shorter and then send them over to the YouTube channel, and they can get a really good understanding of what would have taken us a couple hours on the phone is now maybe a 30-minute, 45-minute phone call, and now they can spend a couple hours on the channel, or 45 minutes a day or 20 minutes a day or whatever. We're actually trying to get them a little bit shorter, understanding what's going on in the diesel engine itself and how the turbo works. Because a lot of people don't understand. The big thing that we deal with is nobody really understands what the turbo does.
I don't either. Yeah, it's difficult because how often do you guys wastegate a turbo? You don't really. You just it's sized to function, right?
Actually, I believe in wastegating on diesels. 110%.
Are a lot of modern ones wastegated? Because everything I know is like dinosaur stuff that it's like pure function and nothing else.
Yep. Most all your modern stuff is either wastegated or variable geometry, which they can just.
Of course, yeah.
Yeah, they just changed basically just changed nozzle efficiency with those to change how much flow can go through it.
Those are the ones when you fire them, they fire and they sound like a NA diesel, and then it chokes off and starts spooling at idle, makes like 5 pounds at idle.
Yep. Yeah, but I think I think they all should have wastegates, because what I really like about turbochargers is all a turbocharger does is it modifies what the engine's asking for. So the faster I can get to 30 pounds of boost and then just gate it and leave it at 30 from 1500 to 3000 RPMs, the better off I am than having this curve that goes up. And then basically that if you were looking at it from probably a spark ignition standpoint, your tune would be like changing the whole way through the curve up and down. And it's kind of the same thing with the diesel engine. I'd prefer to get up to my target boost pressure as fast as possible and then hold that across my RPM range that I want to run through.
Yeah, well, that makes sense. I don't know why I had the assumption that... I know newer ones have VGT and gates and everything else. I've seen like the flapper, internal flapper and stuff on Cummins. But it makes more sense for them to have the geometry, because then they can... It's kind of like compounding. Am I sounding like an idiot? Where they can light it earlier, but then open the exhaust side to work better up top.
People probably, I don't know, some people, maybe most people probably disagree with me. I don't know. But with the VGT stuff, my thing with VGT is it was more of an emissions idea.
Okay. So it's not functional in a horsepower or bottom end, top end situation at all.
Kind of. What we run into with the VGT stuff is we can't put bigger turbine wheels in them. Basically all the mechanical stuff inside that housing gets in the way. And when we want to, basically that turbocharger was designed perfectly for that stock truck. So now someone does a tune and still wants VGT. Yeah, correct. Because we can't make the turbo bigger to accommodate for the motor making more power.
Someone just wrote variable geometries tend to soot and stick up after a while, like the mechanical pieces in the exhaust. That would make sense too. So it's a reliability. It's like displacement on demand in Chevy engines. It's garbage. They added it for EPA and federal stuff, and it made the engine less reliable.
I kind of always give people a little bit of grief, but I kind of, I'm like, if you want the exhaust brake, then you got to stay VGT, or if you want to, not have to take the turbo off for emissions or all that stuff. But I was like, I can probably set you up with a fixed geometry turbocharger that might spool a little bit slower than that VGT one, but we can make double, triple, 4 times the horsepower, whatever you want to do.
That's huge. Yeah. Obviously everyone wants 4 times the horsepower. That's why we turbo 5.3s.
Yep. Well, because you can't spin them 4 times as fast, so you got to use a turbocharger.
Yeah, exactly. My buddy Chris asked the funny one, so we'll just ask that out of nowhere. He goes, I just want to know, can you tow a house or not, bro?
I don't know. I mean, someone just sent me a diagram today of a guy making 1,095 foot-pounds at 2,100 RPMs with one of our units.
That's pretty disgusting.
I mean, yeah. On a 5.9 liter engine, 359 cubic inches, 1,095 foot-pounds at 2,100.
Yeah, that's disgusting sounding. Yeah, so I'm like, part of that is not good for drag racing, but I might be wrong, obviously, because Firepunk is going 3s now. But now, do they have, like, what kind of RPM do those guys spin? I want to talk about them for, like, an hour after these questions.
I'd love to get to talk to them, because I have plenty of questions that they could answer, because they got all the money and all the gauge and data acquisition.
Oh, yeah. It seems
they
like
get to see that stuff.
They're one of the only guys that I've heard say about the Bosch. They're like, we have a standalone for our dyno cell. And those are the guys that spit that billet engine apart that everyone was pirating the video. And then finally I learned it was those guys, and that's when I subscribed to them. Yeah,
no, those guys they're super smart, and they work with D&J. D&J is the engine builder. They build that billet block.
Oh yeah, because they were like, let's just push it till it comes apart, and then they did, and they just laughed about it and threw it across the dyno room.
One of the channels, it's a engine builder magazine, was doing an interview at D&J, and they're kind of not I want to say uptight, but they are careful with how much information they give out. But they were saying that they've recorded 8,000 psi cylinder pressure on a 4.020 piston.
Jeez, that seems like quite a bit, in my opinion.
But that's what they're saying. That's what it takes to do 4,000 foot-pounds torque. But and RPM-wise, D&J was saying right around 5,500 to 6,500 RPMs is about as high as they can push the peak horsepower numbers, just because of the flame speed of the diesel starts. You can't accelerate it enough, even with nitrous. It won't keep up.
Someone just said that like a minute or two before you did. So you can't see chat, so you didn't make that up. It's funny, everything you know. He says Firepunk spins over 6,000, but they make peak power at 5,800 approximately.
Yeah, and D&J was just saying it's a flame travel thing.
It's too slow. The fuel's too slow to RPM any higher, which is something I always new, and that's why some of those stock diesels can't make power over like 4,000,
Hmm.
like TDI and stuff like that. They're just done at 4,000, but it makes sense to have like a full-on drag one do another 2,000 over that.
But they're getting around that with, they're doing some gearing stuff and whatnot. And the big thing too is that, and I don't know if it's a weight thing or if it's if it's a weight versus safety, or if it's maybe it is the RPM and gearing, is that all the diesel stuff is for the most part all eighth mile. There's, I think, like Milliken and some of those guys did do quarter for Sweet 16, I think, or maybe that was still eighth as well.
Huh.
But I've noticed even the trend in pro mod and everything else is kind of going to eighth, I think, just for safety, just because of how fast these things are getting.
Yeah, most of the time, if it's not done in the eighth, quarter doesn't matter when the things are that fast. They're done. Those guys can coast an insane time to the quarter after
Mm-hmm.
they've just boogied to the eighth that hard. And I agree. If you're going 211 in the eighth, why are you running it out the back? None of those tracks are long enough.
Yeah.
And I've heard this too. Years ago, I did a dyno day with some big knowledge diesel guys from the eastern Pennsylvania here, and
Mm-hmm.
BK says the same thing. He says you just can't get the fuel in. The injection rate, your maximum amount of spray, you can't get any
Mm-hmm.
more in the window. The window is
Yeah.
done.
Mm-hmm. Yeah. Well, it's the same one. I've been listening to a lot of the stuff about how all of you guys hate direct injected gasoline engines because you can't make power without port injection, basically.
Yeah, anything
Because
performance has ports stacked onto it. Like, why even have it?
So it's kind of funny though. Is I know like the early DI, your guys' injection pressures I think weren't that high, and recently it sounds like they bumped the injection pressures up to around 6,000 psi. And I bet you if they can, they're going to go up again because the higher the pressure in that rail
More you can
system,
put in, right?
yep, yeah, the more you put in a short amount of time. So
Yeah,
the
early
same thing
ones
happened
were
with.
like 1,000, 1,200 in my opinion, and a couple of them have gone to like the 2, 3,000, and they might be. Chris Ortiz would know. He's in the chat on a lot of modern like DI, L83, whatever trucks and stuff. He would know what they're up to now.
Yeah, yeah. So like the old diesels, they run around 6,600 to like 7,800 psi, and but that's mechanically created, so it's forced to go through the injector. Your common rail stuff, early common rail, I think is 22,000 to 26,000 psi, and some of your latest stuff is I think 28 to 34, 37. I might be overshooting it, but
No,
I
I've
know
heard
it's
at least
next to 35.
20,000, and I've actually heard
Oh
people
yeah.
say you have to watch when you touch anywhere near those because it can directly inject through your skin into your
Mm-hmm.
bloodstream and your body. It'll
So
just
on the
it'll put fuel straight into your body. Like
yeah, on cylinder six on the 5.9 common rail engines, they have a quarter-inch thick of some sort of steel. I would imagine it's a hardened steel next to where the injector line is. So if that injector line broke, it won't saw through the cab and go through you.
oh, some BK must be a very knowledgeable diesel guy also. He just says we run close to 40,000 psi peak now.
Yeah, and I think listening to Dynamite Diesel, the big thing is why, or main reason on the pressure seems to be the injector bodies themselves. If they can, the injector body and the solenoid actuator, if they can handle those higher pressures,
Have to
seems
actually
like they're.
hold it.
Hmm.
It makes sense that it doesn't split the injector apart at that 40,000 psi. That sounds retarded to me. I can't even imagine.
Yeah, I don't know if you can compress gas. Like I don't know if you can get gasoline to 40,000 psi and force it through a nozzle. I
Before
would
it just
imagine.
sets on fire on its own.
Yeah, from the friction. Yeah, I'm not sure. Imagine. I don't know.
That's what I was thinking to myself. I'm like, by the time you squirt it, that pressure probably just, you can't ignite it. It just straight burns, like, at that
Mm-hmm.
pressure.
Or it
Well,
might mix poorly. It might want to kind of start to
might be
pre-burn.
garbage or something, yeah. Well, this is funny. An OM, I'm assuming that it says, how do you get an OM Merc to spool faster? Is that super, everyone uses that OM6 or whatever it is?
Oh man, it could be a long conversation. So yeah, I was talking about the inline five and inline six Mercedes diesels. There's a couple different versions. OM607 is the 5-cylinder. OM603 was the first 6-cylinder with a, I want to say it came with a crossflow head, Then the OM606 was the latest iteration of it, and it used a rotary style injection pump that could be computer changed. But what they would do is they would take the 603 injection pump and send it off to a guy in I think Sweden. He would modify it, send it back. You can put it on your 606, and now you got a mechanically injected 606, and the things will do like 600 real horsepower at 6,600 RPMs.
That's so cool. People were asking. Diesel. Someone asked pretty early on. They're like, Matt, will we ever see a sloppy diesel truck? And I'm like, probably never a truck, but I wouldn't mind stuffing like the OM6 or a 4BT in something like a car or LTD or like a Cadillac for no reason. I have no interest in like the giant Cummins and everything else.
You ever seen the Black Sheep? I think they're called Black Sheep Racing over in the Europe.
No, you send me like a notes thing, and I'm gonna paste it all in the thing of who I should look at after all this.
They're one of the only, or at least early guys that were doing. They had a minivan. What do we call it? A wagon. They swapped a 606 in, and that thing rips. OM606 HX52 turbocharger, so like a 65 to 67 mil turbocharger, and they're keeping up with all the like the 1J and 2J stuff over there with a station wagon. The thing's hilarious to watch because it's.
I want to watch that. I want to watch it now, but we're doing this. You'll have to. Who's it called again? I'm gonna just note it for myself.
Black Sheep Racing.
Okay, cool. I got them written down for. So I guess they were asking how would you make the turbo spool faster, but I think you answered that with the modified mechanical pump.
But I don't think those motors can take a lot of torque, judging off of the RPMs that they like to turn those things. They're an under square motor.
So you don't want to make a lot of bottom end. You just want to get it all in up top.
Yeah, and I know that they did use nitrous to get that 52 to light up. Nitrous assist.
A lot of drift guys do that too. You wouldn't think, but I know Papadakis Racing talks about it, and he uses the smallest shot. You smack the throttle, and it like Holly and a lot of stuff can turn. It literally has an option in the nitrous control to off at certain PSI. So it'll never fire until you're in it and it's above a qualifier, and then as soon as it hits 10 pounds, it's off. So they'll use all weekend. A 10-pound bottle will last because it's only, it smacks it for like a quarter of a second when they're trying to get up on it, and that's it. Then they never have lag, and they have 1,000 horsepower turbo.
Yeah, and diesel and nitrous are made for each other.
That's another question Cameron wanted to ask. We'll try to ask it later because there's a bunch of stuff in between. So now we're going to go off serious stuff because my brain is trying to take all this in. So Wobbly Sauce, this guy's always on the videos, and he goes, complimentary pizza and ice cream question, which means what's your favorite pizza and what's your favorite ice cream?
All my creativity has gone into the metal side of things and engine side of things. So pizza is not too fancy, but we like to get pepperoni pizza, and then we buy more pepperoni from the grocery store, and we just we load on. It literally takes like another 30 minutes to cook because of how much extra pepperoni we load on it, and that's always amazing. Ice cream, mint chocolate chip, or the cookies and the cookie dough is always pretty good, but the cookie dough's got to be like the right flavor. Yeah. Some of those are funny.
This is interesting. Yeah, I'm not much of a fancy ice cream person, so whenever people talk about fancy ice cream, I can't identify. So
they might hate me. I haven't had ice cream in a long time.
Maybe I'm missing out on all this info, but this is a good question. I mean, this is probably a gigantic can of worms, but try your best to paraphrase and summarize is what I always try to do. Because this is a giant goals versus use case scenario, I believe. So let me just ask it now. Joey says, how do you approach sizing a turbo for a diesel versus a gas motor? 100% goals driven probably is the short answer.
Yeah, and I was kind of funny, is I always kind of look at, for your side of the market, you probably don't really look at turbos so much as how fast can it spool up as much. So maybe your idea of how fast can it spool up is probably how fast can it get to maybe 8 to 12 pounds for the most part. And then if you want more, you can turn it up. Usually for us, we're looking at how fast can the turbo get to 40 to 50 PSI. And we need to be able to get there and then hold it over this wide range. What's kind of crazy is, and you don't understand this, is the higher the pressure of the turbocharger, the faster you cross the map per increase in engine RPM.
Yeah.
So we typically try and look for maps that I call them kind of like a hamburger map. So it's really wide here and not as tall there.
But pressure ratio all the way across the board instead of gasoline, you want to go this way, and then yours, you want to go flat.
But I've seen some of Garrett's maps. I mean, they're like this narrow. I'm like, it would be really hard to get this big of an engine to not make boost. Yeah, until here to stay safely inside of that map. And another kind of ongoing joke is talking to someone that knows way more than I do. When I was talking to him about turbochargers, was performance turbo diesel does not operate on the compressor map. In other words, we run way more boost pressure a lot of the times, especially wide open throttle, than most any manufacturer wants you to be at.
So a compressor map is for a gasoline engine.
I think to me, it's extremely helpful for the daily driver and to get an idea of what's going on. So if you're going to operate within those regions, then it's important. So if we're towing or lower engine RPM stuff, or we can actually land on the map, then it's pretty helpful. And even if we're doing dyno stuff, I mean, if we're doing dyno stuff, I can kind of guesstimate where we're at. I can see, are we at a turbocharger, or is your tune wrong, or your injector's too small, is your fuel system not good enough? A lot of the times on the dyno, the turbo is plenty. There's still plenty left in the turbo. And I try and talk to them and say, hey, you might get a retune. A lot of times it's, I paid a lot of money for these tunes. And I'm like, oh, the chassis dyno and the video out your exhaust says that it could be changed. Because there's another 160 left in the turbo. I was like, if you were maybe at 80 to 60 left in the turbo, you're probably you're in the maximum for the day. But if there's like 120 to 180 horsepower left in that compressor, as far as flow capacity goes, I was like, there's something up with the tune, or you're out of fuel, because there's plenty of power. So as far as sizing goes, I asked them what RPM, what is the size of the engine? What do you expect the engine to do? Because we can't have our cake and eat it too with turbo diesel. If you want it to rev to 5,000 RPMs, then you're going to have to give up stuff at 2,000 RPMs, So I try and settle them down to earth after talking to them about what they want to do. So a lot of the times it's 15, is it going to be 1,500 to 2,500? Is it going to be 1,800 to 3,000, 3,100? What's the range we're working in? And how big is the engine? So I can kind of get an idea how much boost pressure we're going to have to make to get the density ratio we need to meet the CFM requirement needed to burn the amount of fuel that I want to put in the cylinder, or I should say the customer wants to put in the cylinder. So that's kind of how we look at it.
Is that similar to where twins and triples is a better, because can you have your cake and eat it too with triples or twins?
Yes, if you so as long as the twins is understood as compound turbos.
Yeah, that's what I mean. Like if if someone's like, I want compounds and I want bottom and top, like obviously you can't have extreme amount of power down low and up top, but I want really good power down low and almost more than I can use up top with twins.
You can. You can. The hard part is wastegates can be expensive, and a manifold with a wastegate port on it can be expensive. So then this stuff kind of adds up, and then it turns into, well, that's a lot of the times, and it says this isn't in a negative manner at all. A lot of the times, the ability to get this really wide power band comes at a pretty decent increase in cost.
What's like an economical single and an economical compound, and then what does expensive mean? I have no idea for a diesel. I know diesel costs like 4 times what gas does most of the time. So
yeah,
I'm just curious of a price range, like ridiculous 10,000 or 2,000. I don't know.
Well, like I said, there's our turbocharger as well as like the S300s and whatnot. So basically, as long as it's under, for a single, we think as long as we're in that 15 to 1,600 range, most people will spend that as long as it's going to do what they want to do. Compounds, it's usually going to be around, probably be in the $2,500 to $3,500 area, just maybe in turbochargers, depending on what you go with. It can be maybe $2,000, 2,200 if you go with some of the box stock stuff, but we kind of feel like you're leaving a little bit on the table going with some of the box stock
That's
stuff.
not much of an increase to have a perfect setup versus off shelf.
Well, then the manifold costs more. It's like you can use your stock manifold if you want with a single, but with the compounds, if you want this real wide power band, you're gonna have to get a Steed Speed or a stainless diesel gated
like a
manifold.
ram horn style.
They're just all log manifolds, and they're around
Oh,
$800,
logs.
800 to 1,000. So there's another 800 to 1,000 on top of that. The gates run for the diesel stuff. They run about $500 plus fabrication to get this all set up. So it adds up fast. A lot of the kits from like Evil Fab, I really like their kits. I mean, their kits can get in excess of 8 to 10 grand for some of their stuff.
So you go from like 3,000 to 10,000 for that. Have your cake and eat it too.
Yeah, gotta be a little careful. We kind of have an idea.
That's a slippery slope, 3 to 10.
Yeah.
So that's what I was wondering. I was like 2 or 10. Like, what is it? And you're like, yeah, 2 or 10. I'm like, okay, that's quite a difference. Okay.
Mm-hmm. There's like where maybe the sloppy mechanic side comes in. If you can DIY it yourself, if you don't got to pay somebody else to do all of it, you can have your cake and eat it too for a pretty reasonable amount. Turbos, wastegate, exhaust manifold, and some mild steel or stainless piping. You can probably get yourself all said and done for under $4. And if you get used turbos, or at least you use atmospheric or whatever you do, the price keeps coming down. So the disconnect is between if you can DIY it or not. Like the other day, another shop that we work with, someone ordered a DIY plate bumper and then wanted our shop to weld it up. And I was like, that kind of doesn't work that way. You're going to spend the same amount. You're going to probably spend more to buy the DIY bumper than pay a fabricator. Not in a rude way. It's just how it works out. We've got to pay our bills to keep our doors open.
Yeah.
You're probably going to spend the same amount, and it's not going to be powder coated than if you just would have bought the powder coated welded one from them in the first place. So
The BK in the chat. BK, where do you work or what do you do? I think he does diesel performance because he said we make about 90 pounds fuel only on a Gen 2 Pro Mod 88 as a reference. It overspeeds and comes apart at 120, which I can only imagine he knows from experience. And then he says, when we talked about $10,000 for a good compound setup, like what you really want, and he goes, add in 15K of trans and converter combo to that, because it's not, people forget, it's not just the cost of the turbos. You probably need a bunch of engine work, and then you need 15,000 in transmission to put that to the ground without shattering and then I'm assuming differential needs to be done and everything else needs to be done at that point.
Yeah, they get pretty pricey.
He's a crew chief for a race truck. Can you say, or are you not allowed to say who?
Ooh, but that's cool.
He also says VS Racing turbos work great on diesels, under $1,000 for compounds. That seems very reasonable. We tossed 3 turbos before learning that 120 pounds is too much. What can he tell us? What's the RPM on that turbo? Like, what's recommended overspeed, and how much were you spinning it to have it detonate?
What's kind of cool too is Firepunk has publicly stated that they've made 158 pounds on their GT55, but I think they're using CO2 or some kind of wastegating. So I think they're getting up to 158 psi fairly early in the run, and then as engine RPM's coming up, they're actually backing off the turbocharger and substituting that with spray.
Oh, okay. So the turbo speed isn't out of control. It's maybe 120,000 the whole time because they're putting it in, and then you say they're like double helixing turbo speed out versus nitrous in to accommodate the airflow, right?
Yeah, that's what I think they're kind of doing with that setup. Because I'm like, the only way to have 158 psi in it, I think they said 98,000 shaft speed at 158 psi. Kind of thinking that they're doing that at a fairly low RPM, and then they're gating off the charger and substituting with spray as they're going down the track.
That's super interesting. I'd love to have them on Firepunk. I want to have that, no offense, the short guy. I forget his name. But they rag on him being short, and he's okay with it. So the short guy. I want to have the short guy on. Yeah.
This BK guy sounds pretty cool too.
Oh, he says he runs for Ragged Edge Racing. He does crew
Oh,
chief for Ragged Edge Racing. Do you guys have a YouTube or something? I'm adding you guys to Black Sheep here of people I need to investigate when we're done. And my buddy Cameron says, it seems like big singles make the most spectacular dyno blow-up videos.
that's because we don't understand compressor speed, rotor speed.
Yeah, and BK says, we don't have a speed sensor yet, but precision figured around 120. Which is funny because I guessed that, but a big turbo can't spin 120, 150. Oh, Levon Miller. Yeah, his name's Levon, yeah. Or Levon, one of them. BK knows that too. It's terrible from 2014, but I will link it. This guy knows a lot. I mean, he's a crew chief for a diesel place. Hey, you guys, Ragged Edge Racing, do you guys pull or quarter mile race or what? And let me know what your fastest whatever. Oh, okay. Well, let's go on to some other questions quick before the live stuff is getting pretty juicy, but I want to ask these people that asked 4 days ahead of time. Joey asked like 6 questions, and a lot of them I think are good. He says, can you spray a mechanically injected diesel? Is there a diesel equivalent of a wet shot? Those are great questions.
So as far as adding diesel to the nitrous?
Yeah, I guess spraying diesel with nitrous, which I don't know of anybody doing, but that's a good question.
You'll probably bend the rods just about instantly doing that.
Oh, you'll hydrolock it or something?
It'll just go off way too
before
soon.
the injection event, right?
Yeah,
And that's a big no-no.
Yeah, most things that are flammable, you need something. You need to use something that has basically okay. I guess we can go back. We can go to this. We use cetane instead of octane, and cetane tells us how. Basically, it gives us an ignition delay period. So the higher the cetane number, the less the ignition delay is. What is ignition delay? Ignition delay is how long does it take from when the injection event occurs and the fuel's in the cylinder to the time when the fuel that's in the cylinder pulls the heat out of the compression stroke and actually auto ignites. So if you look at a cylinder pressure graph, it'll come up, and then when injection occurs, it'll actually start to flatten out the cylinder pressure rise because it's pulling so much heat out of the compression event that it's also losing cylinder pressure. And then once it lights off, it'll spike back up. So cetane kind of tells us how long that period's going to be, or at least gives us an idea to work on. So if you take something that lights off fairly easily, like a high cetane diesel fuel, and you inject it and you oxygenate it and then compress it, it's probably going to go, it's going to go off early, just like those little diesel contraptions where you can put a little piece of wool in there and whatnot and smack them. So what we use is methanol. Methanol has a cetane number that's between around 7 and 8. It really does not like to auto ignite, as well as you guys know. When you run on methanol, it basically can't detonate. So it's really ignition resistant. So you can put a lot of methanol in the chamber, compress it, and it's still not going to light off until the diesel actually lights off first.
Yeah.
So,
no, go ahead. It's all you. Interrupt me, please. I'm the king of interrupting people.
But the cool thing, so this is something I thought about that'd be really fun to talk about, is nitrous. I don't know if we want to do that yet or not.
Yes, we might as well go right to it because it's been covered a lot, and Cameron asked it fairly early on. Nitrous versus propane versus any injectable on top of diesel, which here's what I like to do, and I'm going to take a second to interject myself. I like to say something ahead of time, what I think is right, and then have people say no, or you're totally wrong, or you're totally somewhat right. So I would say that all of those fuels help oxygenate instead of the diesel, so you're getting more air at some point, or on top of that, it's hard to get the injection event in. So somehow all of that auxiliary fuel, propane is a fuel, and nitrous creates air. So one of your issues is getting enough air in with your turbo. So if you have a turbo that doesn't create enough air down low, you can supplement it. Obviously, same with a gas engine. You can get all of that exhaust flow to light a turbo sooner. And then I think propane on top of a diesel is it's hard to get the injection event without hydrolocking, so the propane is just supplementary before the
Hmm.
fluid is getting in there. So hopefully I'm totally wrong on one of those.
Well, the thing with so propane was really cool probably back in the day, but it's not really that fantastic anymore as a performance fuel.
You don't hear about it much
Um,
anymore also, so.
the rock crawler guys love the stuff.
Huh.
Just they can go like well because the tank they can be on any angle and it doesn't matter because it's a pressurized fuel tank.
Makes sense.
But
Gas guys run on the propane too.
I kind of tell people is like name me a propane injected something that is doing fours, in the eighth mile.
Yeah, it's good. I throw that around too. I'm like, people are like, is this a good system? I'm like, is anybody going fast with it? And they're
Yep.
like, no. And that, like I said, I don't like to talk bad about some tuning places or shops, but they're like, this shop is the best. And I'm like, does anybody go fast with their product? And they're like, well, and that's a double-edged sword, right? So
Hmm.
maybe people have 100% reliability with that person, but it doesn't go fast. So if you're looking to go fast, it's probably not your choice. But if they have offshore racing boats that are wide open for an hour, that makes me look stupid.
Hmm.
So it depends on what you want to do. But please go ahead. I'm going to mute myself now.
So diesel responds to nitrous a lot, basically on a twofold. So does gasoline. I was listening to I don't know if you guys the real I've watched the Real Street stuff. Jay over there at Real Street, but they had an engine they took apart that was nitrous and turbo, and it was kind of cool to hear Jay say that with the turbo only, you guys' your pressure event lasts about 12 degrees of crank angle, and then with boost and with nitrous, it's about 7 degrees. But if we look at the baseline of most of the gasoline stuff, unless someone can tell me that I'm wrong, which I would like to be told wrong, non-forced induction, it's about 24 degrees. So if you're going from 24, like 12 to 7, it's about all you can really do with it. There's not much left to go from 7 to the engine just blows itself apart, the closer you get to 0. With diesel being around 60 degrees of crank angle, we're already starting super slow, so we have a lot of room to keep adding nitrous and keep picking up flame speed. And every time we pick up flame speed through a cylinder, because we oxygenate the system, we'll make the fuel more efficient. And because we don't have an AFR rule, we can keep doing this until the thing detonates. And diesel does detonate. I got a really cool photo of one that did detonate, and it shows you how crazy the turbine wheel and the turbocharger cancels stuff out, because out the wastegate, the external wastegate, you can see the shock waves, but then out of the handle coming out of the turbocharger, there's no shock waves. So it kind of gives you an idea how much dampening there is on that turbine wheel, and kind of backs up why the Helmholtz stuff doesn't really work that well on a turbo motor versus an NA engine. But if we look at turbo diesel, most turbo diesel stuff modern day comes from the factory with a 0.43 brake specific. And now, whenever the spark guys get asked about brake specific, they say we don't care, we could just put more in it. The diesel stuff, we can't just go throw more in it. We're really limited on that, and especially because of the whole AFR deal. So if we're at 0.43 brake specific and we're putting in 100 pounds of diesel an hour, if we are stuck at 100 pounds of diesel an hour, but we can add nitrous and go from 0.43 to 0.36 to 0.34 to 0.26 to 0.25 to 0.24, you're going to see it on a dynograph is the power is going to go up every single time. And you can do that until it detonates. You can keep going down. We've done mathematical calculations on stuff that's been at a 0.24 to 0.26 brake specific on diesel fuel, which if you lift the fuel quantity the same, that for that to occur, that means we're making more power. And a lot of that is with the nitrous. And that's why you see nitrous clean all the diesel up, because we stated earlier how diesel burns really slow. So because it burns slow, we do have a lot of sooting. Well, when you speed up the flame front, there's a lot of time in the cylinder to now left over to burn up the acetylene soot particles we've created, and it cleans up all the soot, makes more power. It's a match made in heaven, realistically, as long as you are careful with it.
The
Yep.
BK is commenting again. Right. Oh, he's answering Cameron. Cameron's asking about compounding. And, yeah, he says the turbine doesn't reflect the pressure wave, it absorbs it.
Hmm.
Which makes sense. I always say to people, I have done dyno tuning on an engine dyno, and ever since then my brain can't stop seeing individual cylinder trims because the engine dyno I used had 8 widebands.
Hmm.
So ever since tuning a almost stock LS2 and seeing all the fuel trims in each cylinder, I can't unsee that. So whenever I tune a single turbo V8, I'm like, this is the average of all 8 cylinders, and I know that now. So, each cylinder can be off quite a bit. Uh-oh, what's going on?
I don't know if this comes through or not. This is in one of Darren Morgan's videos.
Oh, SR71.
And he's talking shot cones, and he's like, there's only one instance where you'll see like shot cones on a gas engine, and it's when it's detonating, and it's a nitrous pro mod. That one got a picture of. See if I can get a bigger picture here. So this is a nitrous pro mod, just to make up for it here.
Oh,
so
yeah, one of the cones.
Yep. So we're seeing, so on this nitrous car, the thing has too much nitrous versus fuel volume, and it's detonating. And you can see it. I don't even know if we can see that with our human eye, but a camera picked it up. And then I watched that video and I was like, oh, that's really cool and all. It's really, but it doesn't really apply to missiles because our chamber temperature is so high, because the speed of sound is based off the temperature of the air. Our chamber temps are so hot typically, and our flame speed so slow that you're not going to see a detonation event unless you really got something messed up. And even still, you're probably not going to see it. And then an article came out on wastegates, external wastegates, and should you have them or not. And the cover photo taken by Jason Sands, if I can find it, was a truck that I know of because it's local, and they would go through pistons like crazy. I know the owner of the trucks. I know the guy that worked on the truck, and here's a turbo diesel.
Oh, wow. Look at all that
You
going
see it?
on.
You see it detonating,
You can
though,
see
out
the
of the
pressure waves, yeah.
Yep. But then out of the cone out of this after the turbo has no cones. It really gives you an idea, though, too, a perspective of how much.
And there's not much exhaust there, really, right? So the exhaust is a dump, and then but is the gate is that compounds or something?
Single on spray. It's a single 75
wow,
or 80
so
mil.
the gate is detonating and the downpipe is fine. Interesting. I didn't know that at all.
And I was reading a paper because Cole Sting was asking about running straight oxygen in an engine. I was like, I've read papers on it, and you'll never see it really in the aftermarket. One, because no one wants to carry. It's hard to carry around, say, a 150-pound oxygen bottle, and the amount of volume you need is kind of high. But I was reading a paper on it, and it probably applies to nitrous as well, is basically it's fuel volume versus the amount of oxygen. So if you actually calculate the oxygen molecules, atoms, we say oxygen atoms in the chamber, they say they couldn't put more than 30% O2 in the thing before their single cylinder diesel engine would spontaneously basically detonate. So you can kind of get an idea of probably mass volume fuel versus the oxygen and the charge mixed with nitrous and the ambient air. We can get up to about 28% before it does what that truck did right there. That truck went through pistons like crazy. I mean, they probably put more than 30, 40 pistons in that thing.
So I have a quick offshoot question, since you are talking about diesel pre-ignition or detonation. Can you see that any other way? I mean, we can look at the negative strap on a plug. We can use knock sensors. We can see pumping loss. We can see a bunch of things like the delta drop off, a lot of things. So it all depends on. It's interesting to me that the diesel burns so slow. Is there like a lot of fuel stability there, or is it easy to, once you run out of a delta, is it easy to knock them? Is it so what's going on there?
No, I don't. They're pretty. You just have to probably have the timing advanced pretty far. And what usually happens is they just go off early. I don't even know if it's a. You could say it's a detonation event, because I think the flame front speed's probably still below the speed of sound, but it'll start to make cylinder pressure before TDC, and the engines get really loud. If you're ever around one, they start to rattle. It sounds like someone's basically hitting the side of the block with a hammer.
Even more so than normal, huh?
Yeah. Yep.
That's why part of me is like, is that so you can hear the difference when you roll into one and it rattles totally different.
Yeah, actually, a lot of the times on like a performance diesel that's set up pretty decent, when you roll into them, they'll actually get really quiet. The engine noise will go down when you roll in because you're starting to overfuel the system. You're reducing the AFR through increasing the fuel chamber. Yeah, so the burn starts to slow down a little bit. They'll actually quiet down a little bit before they start to pick back up. The engine noise wise, they'll smooth out. The same vice versa. If you accelerate really fast and then start to kind of coast it, but you're still in the throttle a little bit, they'll actually get kind of noisy. Just because the piston speed's so fast at this point that the compression charge is at a higher temperature. You know, the faster you compress the air, the hotter it gets. But you're putting in enough fuel to kind of coast down, and they'll get real loud.
I have a good one here. Distributor pump versus common rail versus unit injection. So there's three of them there. So mechanical versus common rail, which is electronically injected. I don't know what unit injection is. What is that?
Is it maybe Huey injection?
It says unit. I'm not sure if that's irrelevant. Just do electronic versus mechanical for us.
The thing with mechanical injection, there's a lot of different versions out there, but the most popular one has fixed timing advance. And then if you look at a common rail has variables. Basically, it's EFI, it's electronic fuel injection for a diesel
versus with a common rail system.
Yep. So I kind of tell people, I was like, take a carburetor and lock the distributor at whatever timing you need to make the power you want, and then drive it around all the time.
I mean, that makes sense. I guess they're asking, like, what's easier. I mean, I'm assuming if you don't have a lot of electronics and you don't want to invest in it, mechanical's easier, maybe?
Well, you can make, you kind of go back and forth, is the peak powers can both be the same. You know, a carburetor can make the same peak power as a electronic fuel injection setup.
All the under the curve stuff.
Yeah, so that comes into under curve, how fast does the turbo come up and all that kind of stuff. And then from a fairly OEM standpoint, you probably really wouldn't notice too much of a difference. But when you get into the performance stuff, where our minimum timing advance starts to get pretty far out there, we actually started injecting so early. This is in cases where we can't run nitrous. You start running so much advance on these mechanical pumps that we're killing a crap load of torque. So say a 2300 stall converter is actually stalling at around 1800 just because of how much advance we have in it.
Because the engine, it has no power down low.
Yep, yeah, we just start killing all the torque down low. And that was something we kind of learned. We learned that twofold. One, we bought injectors that we shouldn't have bought, and called the pop pressure was really low. We actually got called up by the guy that we used to build our injectors. And he's like, "Where did you get these?" And I said, "Online." I was like, actually, I don't even know how the thing idled on these. I was like, they that bad? They're like 100% below the opening pressure they're supposed to be. So instead of opening at 260 bar, they're opening at like 100 bar. So they'd open really early and have a really low pressure, long duration spray event. So the thing wouldn't make torque to save its life, even with the engine RPM at 4,000 RPMs. It's just this, we're just chasing the piston down the hole. So we got that fixed, and even still with a good injector, it does everything it's supposed to do, but we're looking at putting a dump valve on it to get it to light up even sooner. Yep.
Use performance.
Well, it's a 727. I don't know if they do one for a 727 or not.
Ask Mr. Pete Nichols about that.
But that's the kind of the big thing is once you get into the racing side of things, now you can negate it in drag racing. They're using nitrous, so you can run a lower timing value with your mechanically injected setup and then use nitrous. And you're going to want to run lower timing anyways with the nitrous, just because you're picking up a lot of flame speed there. And one thing that I would personally like to test, like if I got lucky enough and had a common rail and the tuning and all that stuff, I'd like to see what happens if the thing starts making more power with more boost by taking timing out. So it would have like this curve where you'd have low timing in the lower RPM ranges, and then give it timing kind of through the mid range. But then as the boost pressure gets way up there, so we're starting to get a lot of compressed, heat. We got a high density ratio, a lot of boost, 60 pounds of boost. Say from 40 to 60 psi, I actually start pulling like a degree out and seeing if it starts to pick up power, because the flame front might want to be now a little bit at the lower timing value to get my peak cylinder pressure in the right spot. I think that'd be a lot of fun to try out.
So I had a quick question. So do you have a dyno?
Yeah, I have a mobile Dynojet made by Mobile Chassis Dyno. I believe that's their name. It's a Dynojet 224X.
With the all-wheel drive loaded?
Nope, it's a non-loaded 24-inch roll setup.
Huh. And why do diesel guys talk about so many different tune files? And is it only certain ones that have like a quick switch? Or, I mean, I understand where they want like a drag race one that's at like meltdown EGT by the end of the trap, and then they have a tuning one. Are there any other reasons why, or do guys just like having 75 tunes to talk about?
Well, they like, it's like stacking tuners and everything else.
And then can you explain stacking tuners? Because I kind of know what that is, but...
Okay, that's old school stuff. So you could say, I mean, I like how Firepunk kind of does it, is they have different tune files for different ETs that they want to run, like a lot of their customers. And that's the thing with the dyno. We get a lot of stuff where it's my horsepower is low, or a lot of times horsepower is fine, a lot of times horsepower is high. A lot of the times horsepower is low and the dyno gets blamed for it. But if we compare two dynos, like we just had a Northwest Circuit come out with their Superflow 48-inch roll, dual eddy current setup. I mean, we're averaging within 60 horsepower, that setup with a 24-inch roll and no load cell. Not too bad. But what I like to look at is like this horsepower. If you make, and you kind of do the same thing with your 8s for 8s, is if I make this horsepower on my dyno with this vehicle weight, it'll go this fast down the track, it'll go this far down the full track. So it's a tuning aid. And Firepunk is the same thing, where Firepunk's numbers, not in, like I said, a bad way, their numbers tend to read on these 1,000+ horsepower setups. They tend to be between 150 to 300 horsepower higher than a lot of other places. So if you want your big internet record, go there, or use a diesel Dr. Dyno. But they're going to tune your setup based on their local track time. So if a 790 truck needs 800 wheel, they're just going to tune it to 800 wheel, because 800 wheel in their dyno means they're going to go 790 down the track. So we kind of do the same thing with our dyno. We know that at 600 wheel, it's going to go this fast. At 700 wheel, it's going to go this fast. And we're actually always pretty good on the times. Always pretty dead on.
Yeah, I mean, what's funny is I say that to people. People used to talk about how my dyno is high or low. And I'm like, well, for 15 years, it's been mechanically correct. Like a clock. So I don't know what else to tell you guys. I've been posting dyno videos and track times more than most people have been in business. And I try to say that without ego, but I would say that there's a direct correlation, obviously, and it has never changed. So what else do we say about that?
Well, like I said, I'd like to get a load cell for mine. There's a company, I think they're up, to me, they're going to be up north and to the east, that makes the mobile chassis dyno load cell setups. I think it's actually Mobile Chassis Dyno makes a load cell kit where the load cell flips up, has a hydraulic cylinder, it flips it up onto the deck and flips down with just a coupler, a drive shaft. I'd like to have one for certain testing I'd like to do, and then just for everybody that wants a load cell and still see that their numbers are low, I'd make me happy.
I think we're going to upgrade soon. I think this summer we're going to upgrade the dyno. And I never thought I'd be tuning or running cars with such high amount of horsepower. So now we're looking at, ours is inertia, and I want to get a load cell. Simply because I throw about 6 drive shafts a year. And on top of that, really high horsepower stuff, it's like a 1-second hit. But usually really high horsepower stuff, we do a bunch of track tuning also. So I ballpark it and I make it safe, and then we'll go up and down at the track, and then we'll check mile an hour and everything else. But it would be nice to be able to load the hell out of some stuff that I need to.
Yep. Yeah. So like you said, it's safer because a load cell you can now run direct drive instead of overdrive.
Yeah, you can run first gear from 20 to 40 miles an hour over 8 seconds. Traction, of course, but yeah.
Cool. And we'd like to do and for our turbo testing, I'd like to be able to test all these turbos and hold them at the dyno at certain loads and engine speeds and pressures and see how far we can take each one. So then I could tell a customer, I'm like, hey, you can hold this thing at 40 pounds of boost and 2,000 RPMs at 100% duty cycle, stuff like that. Or you can do 35 pounds of boost for 100%, but at 40 pounds, you might only have about 8 minutes before EGTs do start to eventually creep, or your coolant temperature is going to be, because we're making way more power than what the truck came off the lot with. So you always kind of think about like going up a grade with a truck that came with 160 flywheel horsepower, and now they're coming off the dyno, they can say 400 wheel horsepower. The cooling system isn't adequate.
No, yeah, the BTUs are out of control. People always ask about, they're like, I want a 600 horsepower 2500 and I want to tow a horse trailer. And I'm like, it's not really a problem other than you're going to boil all your fluids.
Mm-hmm. Yep.
You can tune around that. But you're going to have 400 degree inlet, 400 degree oil temp, and 400 degree water temp at some point. You're not going to be able to scrub it.
And that kind of comes back around to the compound thing too. You see this on a lot of compound turbo setups where they'll overheat engines. Not because EGTs are high, just because like you said, the amount of BTUs being
it's creating heat everywhere else other than the intake track.
Mm-hmm. Yeah, and you can only fit such a big radiator in these. You only fit such a big intercooler in them. You only scrub so much of that BTU at a time based on the size of the vehicle. I can show you. I can tell you how to run diesels on your non-loaded dyno if you want. It's
tell me quick because I don't really. I feel like I was going to ask you that. Like, how do you do a pull on an unloaded diesel? Like, I drag the brakes on the car. I try to do dumb shit. I don't really know how to do it correctly. I don't really put diesels on much anymore. A bunch of them completely stained our walls and doors, and I just have no interest in doing them anymore.
So I have I have a mobile dyno, so it's outside. So it depends really on the turbo setup. If it's anything that does not have what I like to call a lockup switch or a manual transmission, then essentially we're going to run them without tack pickup. And it's going to be a horsepower only dealio because they're going to basically shift down every time.
Yeah, I can't get tack pickup on a bunch of these anyway. Sometimes I can grab it off the injector if it's common rail, and I can adjust the pickup to reflect RPM, but it's not always a given.
That's what we've been doing. Well, we used to do events, but that's what we do with events. We have the optical sensor tack pickup deal. Actually, I found who makes that pickup and found the tape from 3M. I have like a 200-foot roll of that optical tape.
Oh, yeah, nice. I thought about getting that too for some cars or doing some other alternatives because my dyno, yours might too, it has that we have a really early one that has that photo sensor, and the tab has to pass through a photo sensor. So it has a beam like when you go into a supermarket.
Okay.
And it has to break the beam to show a pulse per revolution. And it would get filthy and everything else, and it would misalign, it would break the damn... it was like the smallest amount in the world to break the beam. I don't know why. And what I did is I put a 5.3 crank position sensor on it.
Oh, I'll have to look into that, because we had a guy lose a driveline on the dyno one day, and it tore the back of the transmission off, and the driveline went between the tire and the roller at 90 miles an hour. So it's like a Hot Wheels going through those foam rolls and just...
It ripped up the tab and
everything. It out. Yeah, it was enough shot, just vibration all at once to make it hit. So it has a new sensor in it now, but it is a tight fit.
I've had like 3 spares, and my friend who's an electronics engineer would constantly fix, replace, and resolder the photocells until I was like, I guarantee this is a 3 to 24 volt circuit that has a knockdown. It has one tooth, so it's pulse per revolution. And I'm like, how would a crank position sensor, because it's 3 wires. I'm like, so it has to be 5 to 24 volts, and then it has to be signal and ground, and then it has to be more than likely a pulse per revolution. So I took a 5.3 crank position sensor and I used like alligator clips on everything, and I took a screwdriver and went like this, and it showed mile an hour. I was like, oh, I win. So I got
Yeah.
so tired of doing the photo cell that I wired that up, and I actually zip tied it in place as a temporary solution, but it has worked for 3 years, so I have not touched it. So it is
Hmm.
zip tied to the damn weird 10 millimeter offset thing. I'm like, whatever. I haven't touched it. I don't care at this point.
Some like the diesel stuff depends. It really depends on the displacement and the size of the turbo and all that fun stuff. But if it's a mid-range size charger, a lot of the times we can just stage them like normal. We'll get them up to about 2,000 RPMs. Start loading the brakes. If it's kind of a mid to large size charger, we'll go like 2,500, then yank them down with the brakes to about 23, 2,100. We usually like to see about 15 pounds of boost before we do the leave. On the big stuff, we usually have to get them up to about 3,700, 3,800 RPMs. Then we'll use the brakes to yank them all the way back down to 3,000, and we'll pull those big, S480, S475, S480, T6 chargers. We'll yank them all the way back up to about 25 pounds of boost before we let it go at 3,000, and it'll throw down a number, and it'll be right next to their track time or what they do down the pull track as far as where they place in the pack.
I've tried doing that before. I don't think my brakes were good enough at that point, but now we completely swapped out the brakes. We used to have the air over hydraulic, over master, over slit, like all that garbage. Now it has the tractor trailer brake,
Mm-hmm.
where it's a cantilever and an airbag, and you have to have 100 pounds to lift it. So I'm sure that's more powerful than whatever garbage we had earlier.
But we use the vehicle's brakes. So it's a really
Oh, you just
smooth.
smash the car's brakes to slow it down
Yep.
while you're in it.
Yep. And it works as long as if you can time everything out real good, the brakes really won't get that. They won't get too hot, and you can get it to zing up. You can get the boost pressure you need before you do the leave, and it'll read just how it's supposed
Because
to.
the turbo speed's already there, yeah.
Yep. The other kind of thing you could do too is, and they call it cheating. They call it cheating if the shift spike is higher than the
Of course,
than the,
yeah.
the peak, but you can get it in third, like third gear locked or whatever their drive gear is locked, and then you can basically zing the thing up with the converter locked, but then hit it in the overdrive early, and basically it'll be on boost going into overdrive at a low RPM and then go itself up. But I've only tried it a couple times, and I asked the customer, I'm like, hey, you want me to? Because it's usually their numbers kind of low, and I'm like, and if they're frustrated, like I could try this. Your trans is built right because I'm about to hit it with a hammer. Sometimes it works, sometimes it doesn't. But usually it's kind of like last ditch effort. And if last ditch effort don't work, I'm like, a lot of times, a lot of diesels need more timing for a competitive application than what they got. Especially the mechanical stuff. I have a tack light, or what do you call it, timing light that connects to a snap-on tool that goes on the injector, and it picks up injection line swell, and then it'll turn the tack light, the timing light on.
Yeah.
So we can actually see like how much timing is actually lost between where the system might be set at 20 degrees, but when we check it with the light, a lot of times we'll see around 10 or 11 degrees. Not always the case, so don't go out there and add 10 degrees to whatever you got. But a lot of the stuff that comes in, if the pop pressure is low or they got something going on with the injection pump, it's been modified.
Is
A
that
lot of
like an
times.
inductive delay, or is that just built in?
I don't. What do you mean?
Like inductive delay on a gasoline car would be a percentage off during the RPM band,
Mhm.
usually distributor car. So what would happen is there's a delay from when you're commanding, even if your timing's right at idle and you checked it with a timing light. At 3,000, you have this inductive delay.
Oh, okay, I see what you're saying.
And the ignition amount, so if you lock that thing at 17 and it's 17 at idle, say 1,000, and you go to
Mhm.
3,000 and it's still locked at 17, it's not 17, it's lower or higher. And you can change what's called an inductive delay for something like that. So I wonder if that's up with the diesel, like the timing isn't what you're asking for, or if it's just something simple as I saw it recently on like Speed Factory where they had a Subaru where they have variable timing, or VVT, like they can move the
Mhm.
cam actuators, and they could see on the Haltech commanded versus actual because it had phasers and cam position sensors. So they would ask for 15, and it would only be like 5. It would be totally off. And they ended up swapping a bunch of parts, and then they'd ask for 15, and it would do this where it follows it and holds it. It wasn't, super fast because the engine would move back and forth towards getting to that cam position. So I wonder if that's something similar where you're asking for an event and it can't keep up, and that's the maybe not inductive delay because it's not ignition, but it's something like the mechanical or some other delay that's happening.
Yeah, well, like a lot of the mechanical trucks, there's basically two spring valves in the system. You got one valve at the injection pump that has to get lifted off of its seat, and then you have the injector that also has to get lifted off of its seat. So a lot of the times we might, and called the delivery valve for the mechanical guys. It's a shoulder, and it has to lift up and then uncover the shoulder before it actually. So it'll start to lift and uncover the seat, but it still needs to uncover the shoulder to go to full fuel. So like you can change this delivery valve out and totally change what actual timing is.
So it's like a physical delay, not obviously inductive. So you can modify that to get more of what you're asking for, or you just have to understand that it has an offset and you have to physically adjust for that. Or common rail, you have to electronically adjust for the physical delay. Interesting.
Yeah, and we like to do it basically kind of anything we're going to run on the dyno, we check it because we don't know, a lot of times we don't know who built the injectors or how old the injectors are. So we like to get with that tool on there and see where actual time's at. And then we'll run it. And if it on the dyno it performs how it's timed, then a lot of times we can start putting more timing in it and it'll pick up power.
That's super interesting.
Or if they're over time, they sound like crap. And
so after time, they get slower than commanded, quote unquote.
Well, they'll start the event sooner. Yeah, so it'll show a retard on the timing.
Interesting. Man, I'm taking in so much here. I'm having trouble asking questions. So this guy says, let Matt take a spin in one of your 1,000 horsepower compound trucks. Hauling engines around in his Kia will be a thing of the past.
I think he might be thinking of DeBoss Garage. So we don't have anything that's 1,000.
I know Rich personally, actually.
Oh yeah, our pull truck should be around 800 wheel because it's charger limited to 800 because of the class, and it's overfueled. And then we're working on a drag setup that should be hopefully between 550 and 600 tire. We'd like to go run 11s with it without the converter locked.
I've done a bunch of trucks on dyno days where I try to drag the brakes, stand on both pedals. And I've had some where the guys are like, this is going to make so much power, and they're just posers, and it makes 450. And then I've had some where I genuinely would have lost my lunch money. And one guy was like, it makes what? I'm like, well, my dyno reads 1,500. And the one guy's truck, he's like, how high does your dyno read? And I'm like, what a jerk off. Ask me how high no one ever gets anywhere close to. And I'm like, well, 15. And I'm like, you might as well just get out of here with a question like that. And he's like, oh, okay. And it made a little over, I think it made 10, 12 on fuel. And then he had spray. And then it made an outrageous amount on spray also. And I was like, wow, this guy actually isn't full of shit. This is incredible.
I like those people because then anytime I get someone that complains, I'm just like, here, look. This guy did it.
Yeah. So
can you? No complaining.
And that was on a 76. It was on a forced inductions Jose built S476R billet, I think with a 96 backside. It might have been T4 or T6. I can't remember.
Yeah, his turbos. I haven't got to be around any of his stuff, but I know a lot of the guys are running his turbos in the drag diesel scene, and in the truck pull scene.
I've heard jet fuel and diesel fuel are basically the same. This sounds like bullshit. Is it true?
They are close, but their BTU is different. Jet A has less BTUs than diesel, number 2 diesel. The cetane rating is different between the two. And I think then there's not really a lubricity package in Jet A. There is, but it's enough lubricity to work in basically a jet engine injector and pump system, where the lubricity package in number 2 diesel is designed to go through parts that are machined so tight that you check them with air pressure. You don't use feeler gauges. You see how much air leaks by them, and if they pass, they pass. So the lubricity is super important. Like anytime you add anything dry to the fuel, like cetane, nitromethane, methanol, whatever, whenever you start mixing stuff in, if you mix in stuff that's dry, then you do have to supplement it with more lubricity into the fuel itself, or else you'll stick parts basically inside your injection system because it's so tight.
This one a guy asked a few times. I want to go over it. And he says, do you have a recommendation for making 3,000 horsepower to the tire? Like, what would your build be to make 3,000 horsepower on a diesel?
I don't think I've fathomed going that far. A lot of money.
Oh, so here's a good one. I mean, that's kind of a joke. And there's a guy here that donated and asked, and I think I forgot to go over it. And it's his name's Jay Hackett. And he says, ask Bradley for his favorite bang for buck sloppy equivalent diesel engine chassis. Like, what's your favorite economical diesel setup?
I think for the money, basically a second-gen Dodge 12 valve. So that's your 94 to 98 rigs. Prefer if you're in a smog state, like we are, 94 to 97. Those things are pretty basic, and all you realistically need is a valve train package, push rods, springs, retainers, and locks. The head's totally good. There's nothing wrong with it. Swap out the factory head bolts for aftermarket head bolts. That's what we do. We just run a head bolt made by Mighty Diesel. Power Driven Diesel also sells their own version now, but they're a torque to yield bolt. And I've done so many of them that finally one day I was like, I just want to know what they're torqued at. So I got out a torque wrench and I just started turning it up, and they average between 138 to about 147 foot-pounds torque on our head bolts. On those ones, the aftermarket ones, it's a grade 10 bolt. So throw those things in there. Don't do something that spools too fast. A good injector. You probably have to get the injection pump called benched and flowed. It's kind of like if you guys send your injectors in to get them cleaned and they put them on little test stands and they do them. Well, we send their whole injection.
Make sure it can use enough for enough fuel for your horsepower expectation.
Yeah, we get a lot of people that they mod their injection pump, but the problem with modding your own pump, so you can go fast with modding your own pump to a point. You're going to hit at some point whatever that thing was calibrated for. That's all it's going to do, and you're going to have to send it in and get it recalibrated to a higher number. So you can do called gov springs, so we can increase the engine RPM that it'll rev to. We can put called bigger DVs in it, which they add duration. So you got to be really careful with that. You need enough heat in the chamber to burn, basically make that long duration light off fast enough. So we stick with a small delivery valve and as big of an injector as you want, usually a 5x16. This is where you'll laugh or not, I don't know. But the terrible part about diesel is we rate all of our injectors by hole size. It doesn't tell you much of anything, but that's how it's been for the last 25 years. That's what I
always hear fire punks like 135s, 165s, but I'm like, that means nothing to me, but go ahead, guys.
So for the 12 valve stuff, it's all going to be, it'll be like a 5x14, a 5x18, which basically means there's 5 holes in the injector and they're .018.
That seems very logical.
Well, the problem is it doesn't tell you if there's any called body or pintle work. So the lift pintle, a lot of the injector builders that build these really nice injectors can do custom pintle, basically grinds or machining. That'll let that injector flow more and flow better with the same size orifice size.
Interesting. So the nozzle seems easier to understand, but it's completely irrelevant based off of pintle design.
Yeah. So That's what I mean. We get a lot where it's like I got a 5x16 and I run on the dyno and makes 480, and they're like, but I got someone else over here did 700 with this injector, and it's like I haven't ever seen that one do over this on our roller. That's all. You're probably doing pretty good. A lot of times I tell people you're actually doing, even though you're upset for what you had, you're doing a pretty good number. More often than not, it comes to, we see the stuff that has less money put into it do better on the dyno than the thing that has like every part in the catalog.
Overdoing it, yeah.
Mm-hmm.
That's funny how I run into the same thing. And a guy named Bradley T in here says he rebuilds and tests diesel pumps, and DIY modding them doesn't work out very well for most people.
Yeah. What we found is, I always call it the internet idol. So you'll get like the one person on the internet that does really well. And now because they did really well, that means that every other person with that same parts package can do the same thing. And that's more often than not true, because I was once that person. I always kind of tell people too, because sometimes like, no, I'm not that person. I'm like, I was that guy. I bought the big injectors, the big turbo, the big everything, ran on a dyno, and it made 388. And then 2 years later, I bought my own dyno. I was like, we have our own dyno, so now I know we can learn how to run it, and it's going to do great now. The most I ever made on my own dyno with that same package, I think, was like 367 or 374. Could not do more than that. So at that point, I had to say, well, the dyno is actually right, and I'm screwing this truck up. How do I fix it? And this way, I started kind of getting into understanding the diesel process, how turbos work, how injectors work, how like diesel fuel itself works in the chamber. It's very dynamic. That's what I like. Literally on some of this mechanically, or even with diesel in general, you could almost have two tunes for winter and summer if there's a big enough swing in outside temperature, because of ignition delay in the fuel type itself.
What did someone ask? I thought someone said something and I wanted to ask to it. Anyway, we'll just jump on. This one's good. It says, why do diesels make more power with smaller turbos compared to gasoline counterparts with the same or similar displacements? And I would say it's RPM band, and you fill in the rest.
RPM, and we don't have an AFR limit that we have to stick to, so we can crank the boost up really high at a really low RPM, because there's basically the AFR is unlimited in the high side of things. Basically, you can make the AFR spread apart. Like you can go 100 to 1 if you could, as long as the thing doesn't turn off. And then the lower side of things, diesel does have a lower AFR, and the lowest, the stoic number for diesel fuel is 14.7 to 1. I just say 15 to 1 because it makes it a lot shorter to say.
Yeah.
But 15 to 1, we can basically take it from 25 to 1 and go down to 20 to 1, and then from 21, 18, and we keep lowering the AFR and keep picking up power. The issue becomes is that with, say, mechanically injected stuff, or even a common rail with a lot of called US microseconds duration, with a lot of duration, you can't really get too far below about 20 to 18 to 1, somewhere in that region before it starts to haze and then smoke. The closer you get to stoic, the darker the smoke will become. So that's kind of the problem too, is that because peak torque occurs in the smoke region, you do see the smoke stuff more often than not, just because it's hard if like you gave someone a car and then like had all this power, and then they're all, well, would you like it to be clean, or would you like this power? And most younger people choose the power over burning clean. So that's where we kind of the diesel community though has kind of been self-policing that really well, mainly because of the racing scene has become a lot cleaner, and that mainly with nitrous. The nitrous has made the racing scene cleaner, and then because it's cleaner and more people are doing better tunes, it's traversed into the street side of things, where if anybody does kind of roll coal at all, usually the community kind of shuns on that now more than cheers for it.
Yeah, they're making a bad name for. I've said that before when people brought up EPA stuff, and everyone's like, man, everyone's hating on us, and I'm like, you guys made your bed. Like, I had no sympathy for those people. I'm like, It's like people that are like, why can't we meet in parking lots? I'm like, you know what? It's because Honda guys show up and they're banging the rev limiter and driving over curbs and being total assholes, and no
Mhm.
one's stopping them. So it's everybody's
Yeah.
fault now. And then when someone sees 12 cars, they're going to assume that someone's going to run into each other trying to drift a 91 Civic, blah,
Mhm.
blah, me soapboxing forever about it. And I'm like, it's your fault, like you said, for not policing your fellow people and letting them act retarded and etc. And I think I said before, like if you want to have a car meet, have it somewhere that a municipality agrees, and you know what? Take $1 donation for some sort of charity. People won't show up. They don't
Mhm.
want to spend $1.
Mhm.
It's say $1 or more, and then you give it to the police or the fire company or a children's hospital. People
Yep.
won't show up. They won't bang the rev limiter. Like they won't even spend $1 to do something dumb as shit. But they will show up to a Sheets and ruin your night and everybody else, and then that's all people see. Is like I was trying to get gas at Sheets, and some kid drove 75 miles an hour past my kid at a gas pump for no reason. So I want everybody with a loud car to go to hell, and that's where we are
Mhm.
right now. Same with
Yeah.
diesels. One guy blew smoke on a 14-year-old blonde girl, and that's unacceptable. Now everyone, you're all assholes, and that's all. That's all it was.
Yep.
You're all done now because everybody
Yeah,
let that guy do it.
the big thing too is that, like I said, the power level goes up when you do it to a point, set up to 15 to 1, and it's fairly easy to do, especially with the older mechanical stuff. I think a lot of those trucks from the factory came with about a 25 to 1 AFR from the factory, so we're not very far off of where the haze and smoke regions are at. So it doesn't take, you can turn up a pump and it'll smoke because we're so close to that region. In stock form you could smash it and it'll do a little puff. And if we do all the math, we end up being probably right about 25 to 1 at that power level. So if you just turn it up a little bit, now you're already at 20 to 1, and then 18 to 1, and it starts to smoke, and it just kind of looks bad. But so that's where we kind of came in looking at like turbo. And the other part of this though too is there's not, in the turbo technology wise, we haven't had anything for diesels that was that spooled fast enough and had EGT control in it, could make a lot of pressure without blowing up, and it was robust. So there's a big hole in that market. Everything that was out there spooled slower. So like if you picture kind of this situation, I go buy bigger injectors for my truck. So the computer, if it's column rail, or even say the mechanical system, it doesn't know that the injectors are bigger. It still meters in the same, say, 800 microseconds, but the injector's bigger. Flow over's got bigger, so the more fuel goes in the chamber. And then on top of that, I put on bigger turbo. So now the thing spools slower. So I got less boost per RPM until 2500, and before I had boost at 1500. And I don't know really how to tune anything. I just put it all in there and I go. Now it's already dirty out of the bat. So we kind of like looked at that and like, let's get something that spools fast, has a wider RPM range, and makes decent power for the most part. We cover from 500 to 800 the tire. That's most setups, and it's been doing really good. As far as the customer doesn't even have to do anything to get the truck to run cleaner. I mean, we've had some people complain that the smoke's gone, and I was kind of happy about that. Like, all the smoke's gone, and I was like, good. It's like, how do I get it back? I was like, you don't.
I know that's like Gale Banks years and years ago. I remember him saying like he could make 800 horsepower, and he had that Pikes Peak car and some other stuff,
Mm-hmm.
and it would barely make any kind of smoke at all, almost nothing. Like there's some Nissan Ultimas I've seen fuel smoke out of a stoplight more than that thing. So
Mm-hmm. Well, the only thing that's a little bit of a disconnect is the stuff that Banks does tends to be very expensive. So it doesn't really fit like what the majority of people could even do if the opportunity was presented. And
I
he
think
turns
it's
a lot
just
of
because he does so much high end. He doesn't really
yeah,
care about most people.
but it's difficult. Like, some people kind of get uppity about Banks. I mean, my own dad is a hardcore Banks guy. But some of the stuff that he says is kind of hard for the average person to accomplish. with what they can afford to do. Kind of like your burnouts and ice cream deal. Mr. Banks is nothing can smoke, and I was like, well, for nothing to smoke, these people kind of got to have a little bit more money
Yeah,
in
the
their engine
economy
and stuff.
aspect of that is unobtainable at some point.
Mm-hmm. Versus getting something that's pretty fun. You can go to the Wednesday night drags, or you can go to your local pulling track and go have some fun with it.
Yeah, so it's not going to be smokeless, but it's going to be very good, and people won't complain
Mm-hmm.
for the price. Oh, so this one's a pretty good one. What diesel pickup do you recommend buying that needs to be at least 5 years old and to be able to afford it? That's a good question. Like everything seems like it's outrageously priced.
Okay, well, anything common rail, basically, we kind of tell people anything that's common rail injected, put enough money away to buy a set of injectors, and put enough money away to at least do like a home job and like a re-ring. Some of those things have ring gap issues from the factory, and they're out of warranty, so you're going to be stuck with the bill if they do go.
Huh. So those are the most
Um,
common things. Other than that, they're reliable when the injectors work.
yeah. So the thing with the injectors is because the cylinder pressures are so high, or it's not cylinder pressure, injection pressures are so high. Even like micron-sized particles move at a rate so fast through them that it can beat them up.
Hmm.
So usually, we like to tell people every 100,000 miles about is usually you want to get those injectors inspected because you don't want them to fail and knock out a piston. Because when they go bad, they'll like early on the early tuners that just put more timing in the column rails. They were basically water jet cutting the piston bowl lips off of them.
Huh.
It would erode the bowl lips.
That's something I never considered. Is the injection pressure is so high that it can cut the
Mm-hmm.
piston. That's a lot to
Yeah,
take in there. Holy shit.
yeah,
The other thing was, so you don't recommend any brand. They're all good as long as the maintenance is up.
yeah. It really kind of depends on too, like what you're. I always tell people like, what are you okay working on? If you're a diehard Chevy guy, there's a couple of parts on the Duramax that are 15, 18-hour jobs that are kind of like a water pump. You have to take off the entire accessory dry off the truck to get to the water pump. And the turbocharger, everything off the top of the engine has to come off the turbocharger. Once you start modifying them, they're easy to get to. But at the same time, too, I do understand those parts aren't failing all the time. So if it is an 18-hour job, it's an 18-hour job every maybe 10 years. So usually it's not like that big of a deal. Everything looks a lot worse than it is on the internet. You know what
So
I mean?
I mean, I would say, is a Cummins way easier to work on simply because of the engine layout?
Yes.
I
Yep.
would assume so, yeah, because like you said, I've seen Power Strokes where everything is smashed into the top Duramax, the turbo and everything's on the top, and that seems like, I mean, I know they did it for space, but I'm like, why the hell did you pack all of that in like the lifter valley cover? It seems dumb as hell, but what do I
Yeah.
know?
Like I said, we got friends from all the Ford and Chevy side of it that have both we've had some of the highest horsepower stuff from the dyno have been 6.0s that have been sprayed with a big shot of nitrous, and they drove on, drove off over a
That was
thousand
that car
horsepower.
that I said to you that almost pinned the damn dyno. I mean, it did over 1,000 on fuel, and then he sprayed it, and it made like every bit of what the dyno could read without pinning it.
Mm-hmm.
And then he drove home. He drove up from Maryland to Pennsylvania and drove home like 3 hours, whatever. He didn't care.
Mm-hmm.
He's like, "How high does your
Uh,
dyno read?" Blah, like 1,000 on whatever, and then 14 on spray. I was like, "Okay, wow."
mm-hmm. So, like I said, I'm not like anti any of them. I kind of always tell people I'm pro understanding the diesel event and making it work for you, how you want it. So a lot of times it's like we've had a couple customers too where they didn't sell the truck because I mean we didn't even sell them a turbo. They called us up and said this thing's like not drivable, and I was like, well, you have this. I was like, here's a list of parts that you can go order and do yourself, and then see if you still want to keep it. And they would do this, do what we instructed them to do. They'd put their own turbo together, and it was like we get a message back, the next week or so that this is the greatest thing they ever did, and they're not selling the truck now because now it's actually enjoyable to drive.
It's not hot garbage. It's going to cost them $15,000.
Mm-hmm. Yeah, but so if you want ease of maintenance, the Cummins platform, 89 to '07 is the easiest to work on. When they went to the 6.7, that's when the engine bay started to get full of stuff. So that's 5.9 liters, 89 to '07. 07 and a half is a 6.7 engine in a earlier model truck. And then they got to the 4 Gen, I think, in 11 or 12 or 10. So when I think it's 20, it was a big deal in 2010, I think, on the count, new body style. But they've been 6.7 ever since. And the only thing is, be careful with first gens. Everybody loves them until you own one.
Yeah, they seem pretty crappy.
89 to 93. So 89 to 91 will be a non-intercooled turbo diesel truck with a 3-speed transmission and a 307 rear gear.
Dog.
Yeah, so it's great for competing on. Actually, we run a 410 rear gear, 410 gears in both the front and rear axle with a 727, but we don't drive it on the freeway. It runs 4,000 RPMs at 60 pounds of boost down a pull track, and then it goes back on the trailer. So it's great for that. 91 and a half to 93, they did add an intercooler. 92s have a ginormous turbine housing that is the absolute worst thing in the world. They work great for truck pull turbochargers, but they don't work great for street stuff. We take them and machine them out, and then they'll breathe up to 3,700 RPMs.
Here's a question which I think is, oh, no, that makes no sense. Never mind. Nope, it's a bad one. People were asking about nitromethane in diesel fuel.
I think that's what we probably will start seeing at some point in diesel drag racing, if it's needed. The reason, I was talking to someone the other day about the fuel types, is a fuel type manufacturer is going to make a fuel that they can make money on. So when half the industry is, say, drag racing and half the industry is truck pulling, then you have to take into account that half the industry has a set of rules that say you can only have these modifications done to the diesel fuel. So they're going to make a fuel for drag racing and truck pulling, but it's going to have to fit all the truck pulling rules versus trying to R&D 2 fuel types. From a business perspective, it seems to make more sense to just make one fuel type that kind of helps out both than developing 2 fuel types for one another. But I think we'll start seeing kind of homebrew fuels come about in drag racing and truck pulling, called the Pro Pulling League and National Truck Pullers Association, TPA. Adding nitromethane to your diesel fuel is outlawed. So usually when things are outlawed,
it's too good.
It means that they work. Yep.
BK, again, he says industrial injection is already experimenting with nitro.
Oh, it's definitely been done in the past, because both those polling sanctioning bodies have it outlawed. And if you are at one of these big events, typically they'll run sniffers on the crankcase and the fuel to check for it. If you won.
Of course, I've seen, because I know of Jose's work with forced inductions, he always looks at the rules and builds a class killer, and then immediately they outlaw whatever he made. So he's always in that perpetual loop because he's super smart and he can make the things in-house immediately. So yeah, they'll be like, you can't do this anymore, and he's like, I'm going to do this. And then they're like, no, stop doing that. And then he's like, okay. And then he just keeps doing something different every time. There's a good one here. I want to get on to Firepunk when we're out of questions and just have people ramble about Firepunk, because I think what they do is cool, and I'm happy whenever someone who knows about diesels like you, that you're like, I don't care about brand and whatever. I'm like, I've been watching them and it seems interesting, and it seems like they're not brand loyal, and I'm like, hey, I've been watching them to learn more, and you're like, yeah, they're cool, and I'm like, okay, good. I haven't filled my head with garbage. So
they give away a lot of. The one thing, like I say, is that they don't give away all the data that they do have, but you can't blame them for that as well. Of course,
I'm sure they're doing way better than a lot of people, so that's not a big deal.
They do give away a lot of stuff that nobody else has said, but at least I've thought about and proposed questions about, and then started looking for them, and all of a sudden they're in a video either saying that what I found was right, what I found was wrong, or what they are saying and I didn't even think about.
And interestingly enough, that's they probably talk about stuff that it doesn't matter so much what they're seeing, but it's how they're implementing it. So other people can't even do it. Even if they have the stuff, they
Mm-hmm.
don't know how to do it. It's just like saying nitrous oxide makes power, but if someone doesn't know how to use it, it means almost nothing other than they're going
Yeah.
to have to learn ground up. So,
Like
uh,
one of the really cool things I heard Firepunk say, I want to say it was Firepunk, and I think a lot of the teams are now doing this, is they use nitrous for traction control. Because it has such an effect on the horsepower produced with diesel fuel, they pulse width modulate it to control traction.
that just blew my mind. Yeah, because it's hard to, a big turbo setup's hard to light, and then if you have to pedal it, you're knocking turbo speed down, and you can't just throw ignition in and out of it like a gas engine. So, yeah, so if they see they probably have a table where if there's a traction issue, they yank nitrous out and put it back in when
Mm-hmm.
it's not spinning. That's wild.
Yeah,
I'm
yeah,
going to
just
be
because
thinking
yeah,
about that for 3 days.
yeah, just because it just adds so much power on diesel fuel that you can literally. It's like timing cut for you guys. If you do a timing
Absolutely,
cut, you
yeah.
guys can drop 300 horsepower. It's the same deal with diesel. You can pull a spray out of the thing and it'll kill horsepower.
So similarly, on a gas engine, same thing about slowing down the engine and the turbo. People will use like a dump valve and other things to get the engine speed and the turbo speed up, and then what they will run is what's called like an ignition retard on launch.
Mm-hmm.
So if you are leaving at 3,003 pounds and the thing bogs out of the hole, and then you're doing 4,010 pounds and all it does is spin, you can do 4,015 pounds but yank 8 degrees out of it and feed it back in under a second, and you already
Mm-hmm.
have engine speed and turbine speed built up and the throttle wide open, and then the ignition curve is so fast that everything's already lit, you're just not making enough power to burn the tire off. So that's funny, on nitrous they can probably light the setup and then yank
Mm-hmm.
it and then feed it back in as a second into the hit.
Yep.
Cool, that's crazy. Like I said, I'm gonna be thinking about how to do nitrous for traction control on gas cars now. That's something I knew nothing about. Oh,
Yeah, I don't think you can't really cut a cylinder on a diesel. It'd be interesting to see what would happen. I
it's
don't
just
know if they.
going. It's already going. BK says,
Yeah.
Matt, we already do all of that with diesels.
Yeah.
Some of those things. Or we do all of those same things, he wrote. I'm sorry, I read it wrong like 3 times.
On our chat on my dyno, say real quick, on my dyno, one of the guys that has the fuel only. No, fuel only is a funny thing, but we did a fuel only record just because, mainly for safety, to be honest, at a dyno event. We don't need a bunch of people's nitrous spraying for a record
Yeah,
for
we've
money.
all seen the fireballs on the mobile dynos.
So what he did is a fuel only thing, and what he did is he actually wrote a dyno tune for an inertia dyno that pulled a lot of timing during the spool phase, and it was probably the dirtiest thing you've ever seen. But on the inertia dyno, it allowed him to get the boost pressure up even higher than what you could foot brake it, and the thing did 1,085.
Like an anti-lag, yeah.
Mm-hmm. Just on diesel, it looks terrible though, but it worked.
And then this one's pretty cool. I thought about this too. Would a hybrid electric turbo be good for cleaning up diesels on acceleration?
I think so. This is kind of maybe one of my gripes with Gail Banks, is he did it a long time ago and then never did anything with it. With Garrett Turbo Technologies, their pusher
And
truck.
F1 is doing it now and a bunch of other things, yeah.
Mm-hmm. So his pusher truck for his land speed stuff, they needed more torque out of the hole with it, I guess. So they built a electric setup. They used a Garrett electric turbocharger back in the 90s, I imagine, and paired with the regular turbo on the manifold. And they could turn that on and instantly pick up torque, because you could turn that on and then stomp on it. It's like having a supercharger without the belt drive slapping this crap out of your bearings.
And that's one of the other questions I have reserved. What's funny is BK, I mean, a lot of people are running a dump valve, so that's completely transmission separate from diesel, gas, whatever. But he says, we're doing dump valve too. And then interestingly, he says, we have a speed sensor now in our wastegate and dump valve, which is a LS drive-by-wire throttle body, are controlled based on turbo speed. So we launched the turbo at about 100,000 RPM. So they wait till the turbo is going 100,000 and then modulate dump valve and everything else from there, which makes sense. You want to get the turbo lit. You don't want to be waiting for drag racing. If people don't know, you don't want to be waiting for the turbo to light. A lot of those people, like I know, on a big turbo drag radial car, they might be asking for 75 pounds of dome. They want 60 pounds in the manifold, and they have to wait for a second and a half to get it. And for a car that goes 370s, that's an eternity. That's a 30% of the pass, is they're waiting for horsepower. So similarly, I understand, the diesel and the fuel and everything is kind of lazy and slow. You want to make sure the turbo is well into, because I'm assuming the ones that are slow are just taking forever to light off.
Well, too, that's what you're seeing in the diesel industry is more and more people are understanding that they need to run. And we try to recommend higher stall converters for a lot of these too, but I try and tell people because they're like, well, the shop recommends an 1800 stall. I was like, look, with the 1800 stall in this turbo, you're going to be sitting there trying to stage this thing, making a mess for like 30 seconds.
It's like the 2Js where they just squirt a little bit of spray now instead of 10 seconds on a trans brake. It's 2 maximum to make 60 pounds. Yeah.
Yeah. So then we try and get like a 23 or 2500 stall converter because really realistically now with most, so there's other stuff going on in transmission world, but for the most part everybody's on the lockup trans and the amateur to maybe slightly whatever is in between their level of diesel drag racing. So for the most part, we're all relying on lockup to get down the track. So when we're relying on lockup, you can realistically kind of convert the thing wherever you want. So converter wherever it's the safest, because once you get staged, especially if you can stage in diesel stuff or even maybe gas turbo stuff, if you can get in there staged and then get him stuck on the converter, it's like you're going to win.
Yeah.
I was like, or if you have a blooper and get out of it and have to get back into it, you will be able to get back up on the turbo in time to hit the tree the right way.
It makes sense. The lockup stuff on diesels is interesting because a lot of drag race people don't lock up. What they do is they dump, or they have a 2-stage dump. So they'll dump both obviously when you're going 211 in the 8th on a drag radial car, you have a really tight converter and you dump both, and then partway down they load one back in and then they load another, so they're staging the transmission back in the whole way down the track to tighten it, so they almost have like a CVT. But all that stuff's crazy, but that makes sense where just converter the hell out of it, get the thing rolling, and then when there's a certain mile an hour, just start locking that converter.
Yeah, most of them, we work with one guy that's 850 at the tire, and the thing it goes in the lockup in second. So it launches first, and as soon as it goes in the second gear, so it's second gear locked, and then a second to third gear shift locked, and third to fourth locked.
It's funny to think how simple a gas setup is to race than a diesel at this point when you're talking, because that's fairly advanced gas stuff we're talking about, and diesel guys are just, it seems like they're just implementing that. But it makes sense where gas guys have been doing it so long, diesel guys really are like, I'm just going to foot brake it forever and then launch. And whatever I have. And now some people are like, dump valve, this, that, turbo speed sensor, 3-step, whatever. Yeah.
That's what we kind of plan on doing. I mean, we get a bunch of crap for our 727 being a 3-speed. Everybody wants us to put a 47. Basically, it's called a 47 RE or RH. It's a 4-speed with lockup. And I'm like, build one of those to hold 1,000 horsepower for what we're doing is going to be $6,000 to $10,000.
Similar to a TH400 bench built at your house versus buying an insane 4L80E is quite a price difference.
Like we built the 727 for I think me and Spencer probably had under $800 to $900 in parts, and I've been building transmissions I'm not like Logan built or Hughes or anything like that, but I've been doing it. I did it long enough to have a pretty good understanding of it. So we built the 727 for 1,000 horsepower, and it's been fine. And we get questions like, how do you get the shafts to live? I was like, well, we stalled it up. We stalled at 2,300 instead of like a low stall converter. So then when we do make the shifts under power, there's a lot more cushion in there with that higher stall converter than the lower stall.
And that's
but I do like.
Oh yeah, keep going.
I do like the idea. We're gonna do the dump valve for now, but it's called a basic dump valve, where we're just gonna dump what we can out of the cooler lines until we break it. And then once we break it, I was like, I'm pretty sure we can probably drill from the outside into the converter passage.
A bleed valve, just
yeah,
a nitrous jet.
I'm like, then once we do that, I was like, dude, let's stall this thing right back down to like 1500, 1400, and then just run a dump system on it so we can just bring it back in as we need it. It's like, and now we got a 727 3-speed that has like a converter slip percentage that's real tight, and now
you can PWM that too.
Mm-hmm.
And then that's similar to now the popular thing with stick shift cars is a bleed valve. Because you can have a triple disc that just hammers everything so hard it breaks everything.
Mm-hmm.
And then it's hard to launch and it just breaks axles and breaks an input shaft. But you put one of those bleed valves on and nothing breaks and it's consistent, and yeah, it's a game changer.
I think if we were drag racing, we would have to, A518, which is the 4-speed non-lockup, or 47, like we are doing in the other truck. But for truck pulling, just having lockup just sounds like a lot of, it is a lot of broken parts. When you basically have, basically it's under full load for about 45 seconds, and it's making 2 shifts during that. Having a non-lockup setup, that especially if we get to the point, that's why I listened to like a Hughes podcast, and I'm like, this sounds really cool. I'm like, I had no idea that these Pro Mod guys were running like an 800 stall converter with like 2 dump valves on it or whatever, so they can drive them around on the dump valves, and then they would just close off the dump valves to lower the converter stall as they get on the track.
Yep, so you can have a giant converter, or I mean a really tight one, but it can be giant. He actually, BK has a wealth of knowledge here. I love that he's like the only person in the chat posting. It's incredible. He says both dump valves in the trans and one in the charge pipe, which is drive-by-wire. And then he says they're doing the double dump and the dump valve on a charge pipe with boost pressure. I'm assuming to keep the turbo lit. They're dumping it to keep the turbo speed up. And then he says they ramp it all back in, 2 stages of dumps and PWMing the turbo intake charge pipe dumping, and they do all of that in first gear, putting it all back in. That's insane to think about. I mean, I wonder how long the event is in first gear, like how many seconds, like under a second probably, getting it all, like a drag radial car. It's got to be, all of that info is happening in a half to a full second, and then that's it. Like basically in the 60 foot, because that's, like we said, 8th mile. What does it matter if you're going to the quarter? The 8th has already dictated the entire win. Insane. Then it locks and stays locked till the end of the quarter. 1.4 seconds max in first gear, he says, for double dump, or a charge pipe dump, and double transmission dump. Pretty crazy. Just past the 60 foot, yeah. A lot of people don't realize that. Really fast stuff. It's all happening really soon. I mean, like I said, if it's a high 3 car, 1.5 seconds is more than 30% of your pass, and that's it. That's the decider. Our best 60 is a 1.3. 1.30. How much does that vehicle weigh? Is it a truck? But yeah, so we'll move on to 6,000 pounds. He wrote. Jeez. What is that? Do you run 8th or quarter? This guy does a lot of diesel stuff, apparently. Well, he's a crew chief for a fast company, so.
That's what was kind of fun, is kind of hearing from your side of it. Like other, YouTubers, podcasters, is there is like this big disconnect between what's actually really going on in the diesel industry right now versus kind of what was going on. So like what's portrayed, kind of portrayed as coal roads for a long time, but up to current, we're running, 390s and 420s in the 8th. 420s and 430s are basically consistent, but anywhere from a 420 to a 4.6.
You just don't hear about them. Like, you're right. I don't hear about it. I don't see it at all. Oh, he says it actually runs 155 miles an hour out the back, geared out. Cool. Yeah, that's rolling for 6,000 pounds.
Yeah.
People were asking about twin charging, like supercharger and turbocharger stacked.
Banks is playing around with that again right now, but there was a guy, I'd have to look at the photo. There's a guy that did it back in the day that did that, and he had a big single charger going through like an Eaton. I think it was like an M80 or something like that, and it would make 120 pounds of boost with only 60 pounds of drive pressure because it only took. Or, I mean, this was what was in the article, I should say. But it would only take 60 pounds of drive pressure to get that turbo to 60 pounds of boost, and then the supercharger was adding another 60 to it. So it would be an interesting situation where the motor breathes from an atmosphere that's at a delta double above what the exhaust delta is. So I would imagine, like, maybe in that circumstance, like cam setup would be like a different cam than what we would see in a normal turbocharged setup. I'm not sure, but it has been done successfully.
Well, that's what I mean. I guess I would ask the question, is a twin charge setup street feasible versus a compound or single? Like, what makes more sense? Probably compound turbos, because almost nobody really twin charges. And if it did work, more people would do it, in my opinion.
Mm-hmm. I don't know, like, if it probably has to have some sort of nitrous or water system on it. I would imagine 60 pounds of boost out of a blower is probably pretty warm.
Yeah, I guess that's the big issue is blowers just make so much heat. I mean, even on a gas engine, in my opinion, they're just spraying heat like crazy most of the time. Or you have to get a blower that's so gigantic it costs more to spin it than it does to make power. It's oversized. Or
Nice.
well, yeah, there's just all sorts of. I feel like
Floors, yeah.
blower cars are just throwing belts or spinning belts, or to make any decent power, the blower takes so much drive that it's shredding belts.
Well, it's kind of interesting too. Is like some people like him, some people don't like him. I don't know. The info he's given out, as far as I can tell, seems to all be good. But like Tom Nelson and Nelson Racing Engines, he talks about what the crank bearings look like on a blower motor versus a turbo motor.
It's that people don't realize this, that it's pulling on the snout. When you have to tighten one of those belts to where it won't slip, and if you understand that all what that is doing to the front main, you're like, wow, you don't even want to pull it that tight anymore.
And then another with Real Street, as well as another one I was listening to, is turbos tend to keep the piston always loaded. The drive pressure and boost pressure seems to keep the piston always under compression. So the bearings are always pretty good. One of the things that was kind of interesting that I've heard said a couple times is, and it seems to hold relatively consistent, is that on these turbo systems, if you, like on the 2Js at least, when they're doing a bunch of RPM and a bunch of boost pressure, then you just let out of the throttle at the end of the track, and it just throws it just tears the wrist pin right out of the piston, because all of the load comes off of the thing on one side, the intake side, and it just yanks it apart.
On the blower, because it's spinning that unit so fast, it's such a load.
Well, that's what I would come back to. So you see it on turbo stuff and they just let out of it, but then on blower, it's at all times. And I've also heard it from a local engine builder, the same thing, where if they get the primaries too big on a blower setup, or the exhaust flow too high, and Darren Morgan kind of, I think, elaborates a little bit on this with why he chooses the exhaust valve size that he does. But even a local engine builder that competes with the methanol pull tractor, big block engines, the mountain motors, when they get the exhaust flow up too high, it'll just eat pistons. Eat pistons or burn up crank bearings.
My buddy Chris, and I've seen this actually. I was privileged enough to get involved with my friend who has really fast cars early on, and he says they make a support system for them now, like a blower. He says you can break the snout right off of a Coyote motor, and I've seen, and I probably have it in one of my really old videos from like '06 or whatever, but I've seen like the Ford pushrod 5-liter engines, and I've seen a adjustable cam buckle from the crank, like the front of the block setup up to the blower, and you could preload it so it wouldn't pull on the snout so hard. I've seen that in the bracket setup to actually put some load on the blower so it doesn't yank on the crankshaft as hard. But yeah. Here's another one. Well, this is a good one. Does Brad do any truck or heavy equipment tuning? I know it's rare, but it happens when I rebuild stock engines with delaminated rod bearings.
I don't, but I do know some people that do. I don't know if they're still in that business or not. I haven't seen them in a little bit. But we've built some turbos for some guys. Some turbos are just general fabrication for some people that do heavy equipment like reflashes and retunes.
And this BK, who's been going off, not for any bad reason, but been blowing down facts all night. He says I should see if I can get Brian Loans from Hart's Diesel on, which is funny because Brian Loans to me is that the guy that works for like Motor Trend or whatever, and he's like he talks the whole time like people are drag racing, like he's a fairly well known announcer, I guess. But that's funny that someone is the exact same name that works at a different diesel. What I want to get is the fire pump guy on, Landon or whatever his name is.
I think you get like that would be a really good episode just because of the two sides of the tuning spectrum would get to go at it.
Yeah, he just has an extreme knowledge. Just the like you said, the fact people are just like whatever, and he has all of the stuff in his head. He's like, we did this, we did that. We did a separate tune-up, blah, blah, microseconds, blah, 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 CP, whatever, dual CP. He's like, millibar was falling off, blah, blah. You know, like, I'm like, wow, he knows everything. And I'm wondering, does the stock computer have that much data that he can just see it all, or do they have external data logging? And that was going to be another question for me. Do you have some setups where you can't get enough data, where you have a secondary data acquisition device on top?
We mainly deal with mechanical stuff or a very limited amount of electronic controlled stuff, so 98.5 to O2. And it's usually an onboard data acquisition setup. There's a company, there's actually another place. Well, if you want to use anything, that's what's made it really easy, I guess, is because the computers are so smart. As you know, with all the EFI stuff, they know exactly what's going on for the most part. So a lot of these new OBD2 monitors that you can plug in, they have a lot of those have data logging functionality. So like the Edge CTS2 and Edge CTS3, it can data log whatever the ECM gets and PCM gets. It can do a line graph of it over time. And
can you export that to like a CSV? And okay,
I think so. Yeah.
My other question about that is usually on an OBD2, the ECU is like frame rate limited. So the more fields you're logging or PIDs, the slower your frame rate is, or samples per second, or whatever you want to call it, frames per second, etc.
I wouldn't be probably the best one.
Well, like you said, you do a lot of mechanical, so that's a shitty question.
Yeah. We mainly just look at EGT, EGT boost pressure, and mile an hour fuel pressure, stuff like that.
Oh, he says, sorry, Matt, I had two things on my mind. No idea why I wrote Brian in there. Steve Hart is the guy who owns Hart's Diesel. That makes more sense. I'm like, Brian Loans is an announcer, and that would be very strange if he had the exact same name as a diesel owner. Anyway, yeah, so those are like where some interests I have, because I have like with HP tuners and stock ECU stuff that I know of, if you have an older ECU and you're trying to log as much stuff as you want to see, your frames per second is so low that you can't really see what's happening. It'd be like having a radial car that can only record 3 frames per second. So you have 9 data points on a 3-second pass. And you're like, okay, this is useless because so much has happened in 3 seconds. You want 100 frames or 100 hertz or whatever.
Yeah.
Oh, Hartz makes Larry Larson's 145 millimeter single turbo. That's all I need to hear. That thing's massive.
Well, there's that. So as far as like the big dogs go, there's a couple of big dogs in turbocharging. And what's kind of cool is a lot of our turbo tech has came to pro mod and the street stuff. I mean, to probably the only reason we're starting to see bigger turbine than compressor wheel setups, like I say, like a Precision 6268 and what is that? They got like a 78, 88, and all these sizes where normally a lot of the gas stuff was always bigger compressor, smaller turbine. But all of a sudden, when the class becomes limited to the compressor you can run, now we're starting to see turbines go up and the power potential of that, or the horsepower capacity of that compressor wheel, we now see wasn't even fully utilized with a 6262. A 6262 still left power on the table. So we go to a bigger turbine to gain engine VE and go up. And a lot of that has come from the competitive turbo diesel world because we run so much, and it's more of a boost pressure thing. So it's when the boost pressures start to get up there, you need more turbine than compressor to rotate that compressor faster.
More leverage.
Mm-hmm.
Which is something I learned. Sometimes a bigger turbine spools faster and works better. Counter intuitive to what you would think and what I learned. And then also, I think the rise of that large turbine stuff has made huge leaps for like imports too. Similarly, you're working at such a weird pressure range, having the bigger turbine, because I've noticed stuff like Real Street has 1,000 horsepower turbos for like 3-liter Supras now, and they're like 78, 88s. They're like a little bit off, like you said, of what you would expect. They're smaller compressor, but again, I guess they figured out they were underutilizing a big compressor, and it was making it slow to spool.
Yeah.
And then at some point, when it would light, that they didn't have enough backside to continue horsepower without choking.
Yeah, and that kind of too. The other thing is I do like what I think you had an interview with Robert Young.
Yep. Force performance. Yeah.
I liked how he stated it, where basically one, if you're not going to run a lot of boost pressure, but you are going to run a lot of engine speed, then the turbine wheel can get smaller because you're not trying to drive the compressor very hard. And then two, if you just want something that's very safe that you don't have to worry about over speeding, the thing goes inefficient before the compressor can get going so fast it becomes dangerous.
Yeah, and then he was saying, always in what I've learned over the years and what I've seen work is you want to stay away from like 2-to-1. You want to get close to 1-to-1. And then he's like, that's not always the case. If you have an efficient turbo design, 2-to-1 is where a bunch of them love to be. They'll make a fantastic horsepower, and they actually have better average power bands because like they're spinning and working on both ends. And I'm like, part of that doesn't make sense to me, but I believe you.
So this might be something that you can maybe play with before I can, or if you're interested in it, is expansion ratio, which is it's just like compressor ratio, rather than it's the drive pressure versus the pressure on the backside of the turbine wheel. And this is how they rate the flow ratings on turbine housings and wheel selections. Because what's pretty interesting, I never thought a housing really made a big difference until I did 2 housings. One of them would maintain 1-to-1 for just about everything up to about 3,300 RPMs to 3,700 RPMs. It'll hold a 1-to-1 pretty good. And then I made another housing that was even smaller than this one, and it was a lower horsepower rating. It runs like 2-to-1 at all times. So the same rotor assembly. They're both the same size turbo wheel and compressor wheel.
Just the housing.
Yeah, just the housing changed, and now it runs 2-to-1 at almost all times. But there's no EGT issues, and it makes the horsepower that we expected it to make.
And that's what Robert was saying. Yeah, you can have a better setup, and I mean that makes a little bit of sense because I've done like 78, 75s make fantastic power all over, and then you go to like a billet 80, 88 T6 from the T4 96 or 125. And you go to a 80, 96, 135 T6, and it has almost the same horsepower per pound, almost the same final horsepower, but takes longer to light it, but has fantastic back pressure, but all the horsepower figures are nearly the same. So part of that in your head is like, why the hell is this happening? But that it makes sense, like what he's saying is... it's relative at that point for amount of power or power band and all sorts of things.
What we found though is like there is like it's always kind of, I mean, if we're talking about like turbochargers at all, is that a turbocharger had to be designed by somebody, like they didn't just like CFD up a turbo and say, here you go. So
yeah,
always
it's application specific, obviously.
Yeah, I was like, at some point, someone said, I have this engine, it needs to make this much power, this engine speed, has this many cylinders, so the displacement per cylinder. We know the turbo is going to be mounted in relation to the exhaust valve to the turbine wheel. The engineer gets all this data, and then they're given a task to build it. Or generally speaking, a turbocharger has to be reliable and do everything that's asked of it. And then we come along and say we want to put that turbocharger on something else, and then either one of two things happens: it works really good, or we complain that this turbo is a piece of crap.
Yes. When you
So we,
improperly size it and you hate on it.
yeah. So what we found is generally changing the AR of a housing doesn't have that big of an effect on the horsepower potential of a rotating
That's
assembly.
interesting, yeah.
Um, you can go like as long as say if it's 1,000 horsepower compressor wheel and you went from like a 132 to a 158, well, it's still only going to do 1,000. It's just going to do 1,000 a little bit later because you're going to still have the compressor max. But we had a case where we had a compressor, let's say, good for 600, and we changed the housing on it, and it went from being good for 600 to 400. And then we could actually go bigger. So it's a 6 centimeter, then there's a 9 centimeter. We do a centimeter for all this.
Yeah, that's
European
always
stuff.
one thing that diesel. I was going to say, so what is the centimeter to AR ratio? Or are they just totally different in a diesel where it's not comparable?
Totally different, and they're frame based. Just so like a AR ratio is foot based. So if it's a T4 0.91 versus a T3.91, they're going to be two different actual
Yeah,
size
it's like a
housings.
tire ratio, I tell people.
Mm-hmm. So same with the centimeter stuff. Other than instead of being foot rated, it's we call it frame size related. So if you had an S300 with a 17 centimeter and then an S400 with a 17 centimeter, the S400 is bigger. So it follows the frame, not the foot size
Yeah, of course. Yeah, yeah.
in that case.
Which makes sense. Same
But
thing with gas.
yeah, so we have a 6 centimeter 2-to-1, 9 centimeter 1-to-1, and then we go up to a 12 centimeter, and it would go back the other way to not being. It would go. The drive would come back up again. So we kind of found out that it does seem to be an optimum what an engineer calls an angle of attack, which is the angle at which the gas enters and drives against the turbine inducer. So there's like an optimum spot for that to be to get the most work done without adding any additional work from the flow itself. You turn the engine RPM up or put more fuel in it to
Just
increase
blade
it.
design.
Yeah, so I kind of tell people it's like everything's designed to do something, and so like if we look at a kind of a lower, this would be on a diesel setup. I don't think I have any gas.
Oh, so BK just says on nitrous we're well over 2-to-1, and on fuel we can just barely hit 1-to-1. It's crazy how much exhaust volume it adds. One thing that I'm really interested now, since you saw that, is my buddy Cameron has that Crown Vic that goes high eights on a stock bottom end 6 liter, and we have been spraying it on and off. And now my curiosity is peaked on what is back pressure on his non-spray versus spray passes, because I mean, like you and I know, that's why when you do E85 is a bit of a cheater on a gas engine because it creates more exhaust gas. So you can spool a bigger turbo at the same as when you were on gas, and the same as for a methanol car will light big turbos on a trans brake way faster than gas C16 whatever. So that's an interesting thing. Obviously, we know nitrous just slams the hell out of it with exhaust volume. So I'd be interested to see now his back pressure data versus spray and no spray. But yeah, sorry, angle of attack. I think you were after.
Yeah. I was just saying, like different housings, there does seem to be like an ideal spot for it to be. But a lot of times it's hard to find, like as far as if the compressor is the maximum value or not. But that's kind of what we do with the turbo diesel stuff. Is there seems to be a lot of the turbine housings that are out there for the S300s, which is like the most popular one. It has a hard time running above 40 pounds of boost without EGTs getting out of hand. And a lot of these setups need to be able to get to 40 pounds of boost to run clean, if that makes sense. Because if you want to say if you have 2,000 engine RPM and it's running 25-to-1, and then you increase the fuel with a bigger injector or a hotter tune, then the boost pressure has to go up at that same engine speed to keep the AFR at 25-to-1. So you can also see where, like, because this high AFR that has to be maintained to keep it clean, it does start to get really hard to maintain that.
So, Will, I mean, diesels are backwards from gas in a sense. Tell me if I'm wrong, where the fuel adds EGT on a diesel, and on a gas, if you dump it with fuel, it'll basically cool it off to a degree.
I would say correct, but as long as if you're keeping in mind like a duration part of it, does that make sense?
Yeah, like you were saying, the duration is far more affecting than, and the injection
Hmm.
timing and duration is far and above the fuel ratio.
Yeah, because we've recorded trucks making close to 850, 1,000 wheel that are running a 15.0 AFR completely clean, and we had to
Because the
without
injection
spray.
timing was smaller, you were using less fuel.
Yep. Yeah, so it was a very short injection window or injection event that this thing had with a ton of boost pressure and the methanol. We had methanol spray set up on it. So it's a water meth setup, and the methanol will actually pick up the flame speed. It's harder to get it to go off, so you got to add timing to it. But once it does go off, it'll accelerate that flame a lot
Now
faster.
that's
So you're
interesting. Cameron did ask that earlier, but I thought we covered it with propane and stuff. But he did ask about water meth, straight meth, water injection, on top of all of the other propane and whatever else.
competitively like water. We don't really run straight methanol. It just gets too hot. The burn temperature goes up. And it tends to get another thing too. I think what it is that it's hard to get it to mix that heavily in the chamber. So it does create a lot of ridge zones for us, I think.
Oh,
So it'll heat the ringlands up.
so
So we
it's
do a
actually bad
mix.
to just squirt water meth on a stock one. It's a bad idea.
Well, I would say don't run straight methanol.
Oh,
So
okay. So
people.
is there a benefit? So if you bought like a snow performance kit and you put,
Mhm.
I like to laugh and say I tune on washer fluid, and a lot of times I'll just buy the negative temperature because people are like, well, how do I know how much alcohol's in it? And I go, well, swish some in your mouth, and they would laugh like I wasn't serious. And I'm like, if it burns your mouth like Listerine, obviously there's a bunch of alcohol in there. And the blue stuff is just like water. There's nothing in it
Yeah.
but blue dye. So
Yep.
obviously, like I call it Prestone piss water. The bright yellow negative
Hmm.
40-degree Prestone has a ton of alcohol. It burns your mouth. Like there's a ton in it. So we would tune on that straight yellow stuff, and it would work really well. So part of my question would be like my friend Cameron, who said, "How do I pick up some power around towing and everything else?" And BK was helping him out with compounds and some other stuff. But could you just add a snow performance kit that turns on like at PWM? So say it starts at
Yeah.
10 and is wide open at 40 pounds with washer fluid or like half and half. A lot of other times I tell people to buy straight rubbing alcohol, like a liter of each, and mixing it in your tank in your trunk. And then you have 50-50 alcohol water mix. So if you
Hmm.
have a completely stock or a mildly tuned diesel truck, would spraying water meth mix on top of a totally stock tune-up help at all?
I would think on a totally stock truck, it would gain maybe like I would kind of be careful with horsepower numbers. I would say it would gain a little bit because you're adding methanol, you're adding fuel externally to the event. It's going to pick up whatever you add in methanol to it by weight, and probably not as efficiently as if you put the methanol in the diesel fuel and injected it. But like we talked about that, you'd have to add lubricity to the fuel and all
Interesting.
that
Yeah,
fun
because it would
stuff.
dry it out. Similar, it does the same thing on gasoline. You
Mhm.
can't leave that stuff in there. You have to like. That's why on those methanol cars they have those fuel switches to shut the fuel off, so it's not sitting in the damn thing.
But with water meth injection, the big thing where it does start to make it basically the more boost you run and the harder the compressor outlet temps get, the better it works. So that's kind of why I do see a lot of the spark ignition stuff. There's always a debate about it, does it work or not? And they're like, oh, it works okay, but it's not worth the money. And a lot of it kind of comes down to is they're not running nearly the amount of compressor outlet temperature that they need for it to really work that well.
To burn the diesel. That's funny because on gas you want fairly low so it doesn't pre-ignite. But having
Well, it's a I always kind of tell people it's going to be hot no matter what at 60 pounds of boost. So we have to account for it regardless. So 60 to 80 pounds of boost, it'll run like on a super farm stuff, like a 530 cubic inch engine with a Hartz turbo. Um, by the end of the track, it'll be about 530 to 600 degrees on the compressor outlet temperature. And they'll run on those charge pipes because they're not allowed to run nitrous. So we'll have like four to six stages of water injection before the air to water intercooler. And then after the air to water intercooler, we'll have another 4 stages of water injection, and then one water nozzle per cylinder to tune the cylinders.
That's insanity. So how do they turn on all those stages? Do they have a giant nitrous controller, or is it specifically a diesel water spray controller?
It's kind of like I don't know what it was. Maybe it is originally a water injection thing, but it's a big Simpson solenoid, flow pressure solenoid, and it's based off of boost pressure as far as when it kicks on.
So very similar to Snow Performance with the on and off full amounts of PWM.
Yeah. The only difference is it's a belt drive off of like a dry sump pump. So they run about 600. That makes sense
because of the volume.
Yeah, so they run about 600 psi versus 100 to 200 psi with the small stuff, and they belt drive it, so it's a lot more volume. They'll typically burn more water than diesel fuel.
So that's what I was asking is you said stages, but you just mean stages of injection. So it's just a mechanical thing spraying all of those, similar to like a fuel car. It's just mechanically juicing everything, and then it has like maybe a barrel valve, which would be your solenoid controlling the spray amount.
That's the craziest thing I've ever seen. Yeah.
What's the craziest thing you've ever seen?
Oh, like 14 water injection nozzles on a plus an air to water intercooler. But they said it gets about 600 degrees by the end of the track, and on the data logger, because they all run race pack data loggers on a lot of these things, it'll be 600 coming out of the turbocharger, and it'll be about between 40 to 50 degrees going into the engine.
Post all of the cooling systems. Wow. And then probably cooler than that in the combustion chamber because of the individual cylinder spraying.
Yeah.
Wow. That's incredible delta right there. What is that, 550 degree drop? That's dumb as hell. But yeah, that's what I was like, how do you have a controller that runs 14 nozzles in stages?
They just turn them all at once.
But you just meant staged of areas of injection.
Yep.
Okay,
well,
that makes a lot more sense to me. You could have one controller do all of that.
You can tell when they screw them up because when they come on too soon, it'll completely shut the engine off, or they'll start to white smoke real heavy, like white/gray.
Is that what that is? So what is that? I've been to tractor pulls where it just starts pluming white smoke. Is that the water coming on too soon?
Yeah. Yep. Yeah, the water's coming on. So when you burn diesel really, really cold, it burns white like that.
Just like a stove not burning hot enough, it just plumes.
Yep.
Interesting. Wow. I'm learning so much, which is what I hoped to learn talking to a diesel person that's not an idiot. Because people, they're like, more smoke, more better. You're like, okay. That's why I'd love to talk to that fire punk guy, because just the data, like when I start telling someone about Turbo LS stuff, and I'm a hobbyist, I'm not a professional in the least, and I'll start spewing stuff that I know, and they're like, they glaze over. They're like, this is too much. I can't intake it all. So it's cool to have you say all that. But then I'm like, how the hell do you control 14 stages? What is turning on each stage? But you're like, belt drive and whatever, and it's spraying them all the whole time. I'm like, okay, well, that's way simpler.
Yeah. That's kind of like the important though too thing is that's why the truck pull and tractor pull stuff there is always smoke because of how the AFR works, and because they can't run nitrous, they can't run any oxygenated fuels. They can in some cases run a fuel called B100 or some cetane, like some modified cetane diesels, but they by no means are generally allowed to run an oxygenated fuel to get that.
They have all their fuel until the boost hits.
Well, then, if you were in a competition in truck pulling, and the one guy running clean at 20-to-1 AFR was ahead of you, and you could win by going to 18-to-1 AFR, then the guy behind you knew he could win going to 16-to-1 AFR.
Okay.
And because there's no way to clean that up because of the rule set, that's how it is in the truck and tractor pulling world. They call it running fat. But they're going to run that low AFR.
So that's why whenever I go to a pulling truck event, I always say, it's not flying unless it has a chimney, which you said lighten the candle. So I'd always be like, chimney fire, here it comes, chimney fire. blah, or
Yep.
it would be chugging like you white or black smoke, and then you see the orange flame, and then they dump the thing, and then that's it. Now, a pulling
Hmm.
truck, like a big tractor, is that like direct drive, or does that actually have an auto in it, like, or is it like a top fuel where they just dump a?
It's a clutch. They have a clutch in there, and they usually have a gear set. They usually a lot of those guys will run. I don't know what maybe the big PPL guys run, but a lot of those are like factory tractor gear sets with just hardened gears. They make aftermarket gear sets. So you can get quick like different gear sets for what you want to do. They usually have three they can choose from, like a three forwards and a reverse.
So what transmission do they run? You said they have a manual. Do they
Well,
change a bunch of gears while they're making the pull, or I feel like they
not
dump one?
just yeah, not just one. They just choose one speed to go down with. It's whatever kind of came with that tractor.
Huh.
Yeah,
And they
it's
don't
just
break
nice.
them? That's unbelievable to me. They don't snap an input. I guess because of dirt or whatever. I don't know.
That and the parts are just huge. I mean, if
Uh,
we if you can build a turbo 400 to hold 4,000 horsepower, imagine what you can build a tractor transmission to
I
hold.
guess, yeah, it's so gigantic, it's hard to break it. It's like a Mack truck
Mm-hmm.
transmission. What can you do to it?
Yep.
Other than having 10-speed dual deck eaten shifted thing in a drag radial car is going to slow it down from all the shifts.
And you might kind of have a little bit of fun with this. Is we can kind of go over maybe turbo setups for different classes, but you got like your single turbo classes. Where the limit horsepower of the single turbocharger, and then cubic inch limited 530, 630. I think they might have one step up from that. And then they go into like an unlimited where they'll have stages. Most of those classes can have either I want to say okay, they have up to four turbochargers, and I think they have I want to say it's four turbochargers and two stages, which is the triples. They can have up to another. Some of those can have up to another stage, so they'll compress it once and then compress it again to get up into the 350 psi range. And then there's if you ever get to see them, they're probably the most wicked things because they have the least amount of rules. Is the super stock semi trucks. Um, those guys can have up to again, they're four or five turbochargers and up to three stages, so they'll run anywhere from 250 to 350 pounds of boost on those things.
Huh. It seems ridiculous.
But what is cool to watch though is that when you take those diesel setups and you convert them over to methanol, have you seen the methanol ones? They have spark ignition methanol tractors.
So they run straight methanol in the diesel cars? Wow, I
Yeah.
didn't know that either.
Well, they're converted. They machine the heads for spark plugs and everything.
I think
But
BK was talking about that. They have a mag then.
yeah, and it was kind of like what's interesting, and it really comes back around to the fuel type is like if it was on diesel fuel, it takes two atmospheric turbochargers and a manifold turbo with all this, 250 to 300 psi to get a thing that consumes 500 to 550 pounds a minute to make the power it's supposed to make 4,000 horsepower on diesel. If you go to methanol, you can get rid of the top two atmos and go to a bigger manifold unit and reduce the boost pressure by half, if not more, just because of the BTU content in the methanol versus the AFR it runs. So obviously we know that methanol, the BTUs are low, but the AFR lets us put a crap load of it in.
Yeah, tons of exhaust gas flow, which is like I said about that's the big thing with turbo technology, huge, and then like Honda Civic, like 6262s are like balling out of control, and then E85, and then everything else is just like a perfect storm for having like a pump ethanol 600, 700, 800 horsepower 2-liter car. It's disgusting. Actually, there's a guy, I'd like to bring him up. Maybe we can have him on too. Miles from English Racing he just converted it to all-wheel drive. He has an Integra that's right around 2 liters. I think he told me. It might be a secret. It's right around 2 liters. It makes 1340 to the tire. Disgusting.
Crazy. Well, I've seen, I don't know if you see the videos from way back, but they finally got it in a car. It looks like is Shane T has that compound system with 2 atmospherics and a manifold. It's a 1.8 liter, and that's going to do, they've already done like 23 to 2,500 horsepower on a 1.8 liter engine.
I have to see that too. Who's that?
Yeah. Shane, I think it's Tecklenburg or Tecklenburg, but Shane T. Shane T tuning.
I'm going to look at that too. Black Sheep, Ragged Edge, and Shane T.
He's been around forever. His stories are cool. He learned he got into the stuff by converting a Briggs and Stratton engine to like run nitromethane back in the day or something like that. So.
That's how, yeah, it gets dumb real quick, and then you learn. That's how I learned. How is we did a lot of dumb shit, and then we learned, and we're like, oh, now we're cursed with knowledge.
Yeah, that guy's he's doing stuff in like kind of your side of the industry that's pretty cool. I mean, he's measuring, like he's figuring out how to actually see like the injector dwell time, looking at the spark dwell time, and actually like having a graph plot out of it, and he's doing a lot of really cool stuff.
Oh yeah, so do you know about injector phasing on a gas car?
So I've been learning. I kind of like that batch fire thing. I kind of just recently understood.
And then, so I would assume that I'd love to ask, like, is it similar? Maybe some guys can answer, BK or someone. So I would assume a diesel is basically like phasing gasoline injectors. He can answer that because you guys are changing the timing when the fuel goes in. So on a gas engine, it's taking a regular event and it's just spraying the fuel before or right around the time the intake valve opens. So it can be puddling and then just eat it on a port injection. Well, phasing the injector is giving it the cam events. So then it has the window of when the valve is open. So if you phase it correctly, it's spraying exactly when the valve is open and going straight in with no puddling. So it doesn't have to roll in. And funny enough, it banks on another ideal where if your duty cycle is really high, it doesn't matter because it's spraying past the window. But if you're underneath like 60%, the phasing makes a huge difference, especially at idle and cruise, because you can have an injector and a car and everything that's set up and running well, but it stinks. Like the exhaust smell is overwhelming. And if you phase it correctly, it almost, even if it's catless car on gasoline, you can almost eliminate the smell at idle. It's wild. And then I've had some cars on E85 and other things where I did hits on a locked injector timing, and then we phased them and messed around. We picked up like 30-something rear wheel consistently with a phasing the injector. But
well, something I guess that's similar to that is they call it pilot injection, and the common rails do it. And what pilot injection is it's tuning the how do you put it? It's tuning the compression stroke to be at an optimum temperature. Essentially, it's a pilot injected shot that's going to light off, but it's not nearly anything big enough to really do much of anything but put heat in the chamber. It's not enough to create any kind of pressure that's a negative pressure is going to hurt anything. It just starts to warm the chamber up. And then from there, you fire the main event into this pilot injection event. So all the pilot injection event is burning off. Now we fire the main event into that, and it decreases the combustion lag. Basically, what we were talking about earlier, the ignition lag.
It's a pre-burn, and then also it stops it from slapping the rod as hard, right?
Yeah, it quiets it down. That's why it's a new stuff. That's one of the main reasons they're so much quieter is that pilot injection.
I know when the Duramax came out, someone told me, I believe it was my buddy Ben Tyler. You ever hear of BT Diesel Works?
I think so.
Yeah, he does a lot of plug-in, switchable, crazy CAN bus stuff. And he was explaining to me how they have like the 3 injection events, and one is the pilot, and one is like a full, and one's an afterburn. I don't know if I'm saying that correctly, but I know there's an initial one, and then along with a power burn, and that's what makes them so much quieter, is because it's just not slamming it with the combustion event all at once.
And it's tuning. It's more. I always kind of see it. It's more predictable. If from an engineering standpoint, if I could create the combustion environment, if I could do a pilot shot and now preheat that thing to a temperature that I know what it is. So now when I do my main event, I can calculate how long it's going to take to put the main event in the right spot. So it puts cylinder pressure in the right spot. It softens everything up. So that main pop when the main start at ignition with a single shot is not so loud. Plus, I know what the temperature in the chamber is now. Everything gets more predictable, and they use that a lot of them use it up to about 2,000 RPMs, 2,000, and then it turns off above it. Yeah. So everything's happening too fast.
So that's similar to like obviously just spark advance on a gas car. Is you're lighting it so that it burns the most without hammering the piston down. or if you're
Yep.
pumping, because a lot of stuff anymore with like E85 and other things, it's hard to tell. The tuning window is so gigantic. What you run into, what I run into more than ignition or detonation or anything else, is pumping loss. You can put so
Yep.
much inject, or you can do so much timing advance that you start slowing down the motor before it pre-ignites. Crazy, but you'll start putting in ignition and the power will start diving well before it
Hmm.
ever pings or breaks something. It's absurd. It's crazy how big the window is on E.
Well, that was pretty interesting to hear. Like on methanol, a lot of cars will lose like 800 RPMs, and then like the nitro cars, they can. I think they can only get up to like eight. I mean, if I understand correctly, they can only get up to like 8,000 RPMs because the weight of the fuel
Slowing the
coming through
motor
the.
down. It's crazy
Yeah.
to think about stuff like that, isn't it?
Mm-hmm. That's why, because they look at like heads and stuff. Everybody wants like the next greatest head for their turbo diesel, and I believed in that stuff until we started getting trucks that had heads and cams on the dyno, and they were doing the same power. And I was like, well, what's the problem here? Because they flow more CFM. I'm like, how are we flowing, or how do we have a head that flows 135 CFM, making a 1,000 1,200 wheel horsepower? And to like a lot of people, it doesn't make sense. What I finally did was I got in there with some measuring tools and measured the cross-sectional area of the port in a few places and averaged it. And what was interesting is even though the head flow numbers are really low, the port velocity isn't 550 or 0.55 Mach until 4,200 RPMs on like the 5.9 12 valves. The head that everybody says is the worst head that there ever was. I'm like, these guys don't seem to be stupid, because I'm listening to these other head engineers saying they want 250 or they want 250 feet per second here, they want 550 feet per second in this area. And I'm like measuring out this head and doing the math with the piston speed and bore size. I'm like, this stuff's lining up. Like, that's kind of weird. And then on the peak torque stuff, we can put peak torque at 4,200.
It's
Or I
similar
could
to
put,
where. Oh, I'm sorry.
or I can put it at 1,500, because we found was the turbocharger is the choke point. So it's the turbocharger for turbo diesel is no different than like heads and cams for the gas engines.
Yeah, you're limited by the. That's what people always are like. They're crazy building up the motor, and they have like a fairly small turbo. And I'm like, what a waste. I don't mean to be weird, but I don't think you're getting it, dude. And then honestly, if you build a big motor with that turbo, it's going to choke out sooner because you're trying to put 400 cubes through a smaller turbine. And that's one that people don't get. They're like, but motor bigger. And I'm like,
Yep.
yeah, you're trying to squeeze more sandwich, into a smaller blender here, and it's just not happening. Like, if you're putting a tree stump that's in a grinder, like a wood chipper that's gigantic, too big for the wood chipper, it's going to stall them out or just not work.
Yes.
How do we digress from turbine to wood chipper? But that's how people get it. Once they get the visual when you're trying to dump a California red oak or whatever it is into your grandma's wood chipper, it's just not working. And I'm like, yeah, that's the same. This is a drastic and wildly different. Oh, some guy just wrote 11 pounds of shit in a 5-pound bag. And that's where, similarly, like Holdener, and I've done a bunch of tests where the shittiest cylinder head works the best. And he's done a ton, like we call him the Great 62, an 862 cylinder head. People say it's the worst because it's a stupid truck head and everything else, and it's got the smallest chambers and whatever. But he's done tests too that the smaller chamber has more compression, and on a turbo it doesn't care. It's smashing the air in. So the turbo dictates the power again. The cylinder head really doesn't care.
Yep. It's just like it's a port speed. And like I said, where we go with that is yeah, we can put peak torque anywhere from 4,200 to like 1,500 to 4,200 RPMs just by changing out the turbocharger.
Yep.
So people put in like a big head and a big cam, and then do a turbocharger that's good for like 600 horsepower, 800 horsepower. And the next thing that we run into with turbo diesel, especially the mechanical stuff, and then common rail is rail pressure, is you still have a pumping system that has to pump the fuel in, and that pumping system for like mechanical stuff has a pumping curve. So as the RPM goes up, it can pump more per minute, but it also has a peak. And then after that peak, it just goes flat. And then eventually it'll actually start to fall down. So eventually we'll find that with the turbocharger and stuff like that. But like I said, my joke is that like an 855 cubic inch Cummins will run on a 55 millimeter compressor wheel. So like, because it's a 300 horsepower engine, and we know that this little tiny 55 millimeter compressor wheel can flow an adequate amount of air to make 300 horsepower. The problem is the 6-inch piston going through the exhaust valve is going to just blow up the turbine side of that thing.
Yeah, that's funny because that's what you run into. That was what I learned too, is to make big power, I thought you needed a gigantic turbo. But then as I learned like 2-liter, 3-liter imports, they have what I consider a small turbo, 60 millimeter, but they're making 800 horsepower. Then I realized they have less to shove through the turbine. So the turbine is relative. So 96 is decent on a V8, but a 96 would never light on a 4-cylinder, or it's very tough to. But now wheels are getting better. That really doesn't, I mean, part of that doesn't make sense anymore. But then, yeah, if you shove a 62-62 on a 6-liter, which is essentially 3 times as large, it's going to be awful on the V8 car, even though it's capable of 800 plus horsepower on a 2-liter.
Kind of an interesting study that was done. They used just a pulse jet engine to do pulse frequency testing on radial inflow turbines, basically the turbine side of a turbocharger. And the pulse jet, it would have a pretty drastic effect on either the hertz of the pulse jet or the duration of each hertz, like a square wave, would have an effect on the turbine wheel itself, the turbine housing and turbine wheel. It would have an effect on it up to about 3,000 RPMs. So from 0 to 3,000, it looks like a line basically kind of traveling down this direction as far as its effect on the turbocharger itself. But it's still, we can look at the hertz, like a displacement per cylinder type of deal. You know, the bigger each cylinder is, the bigger each one of those pulses are inside of that turbine system.
Yeah, it's like a lot of stroke. Yeah, that's what I'm curious to see with the engine I built. It's like out of square. It's like it's a stroker but a small bore, which I don't see a lot of people doing. So I assume like it's going to do a bunch of different things. But one of the reasons why I went with small bore is people lift heads on LSs because there's only 4 bolts per cylinder. And so the other thing I did is I put aftermarket heads on. The aftermarket LS heads I have weigh 2 times what a stock one does. And then my builder was saying that the deck it's like 160% thicker than a stock deck. So it's harder to deform it and lift it. And then my bore is only like a 380 bore. So I'm interested to see what it does. But then also Brian Nutter at Summit was saying the stroke will light the turbos off at a lower RPM simply because it's moving more volume with the stroke per RPM, I think is what he said. Don't quote me.
I don't know. I mean, I think it's important to care about a lot of that stuff, but at the same time, I'm like, I could just add more boost pressure.
Yeah, that's the laughable part, right? I'm curious to see, I wanted to build something that makes a ton of power, but on an average. A huge average of power. And then if it doesn't make the power I want, I can just put bigger turbos on and crack my block, rattle a sleeve, and then I'll be happy.
I was like, because like Firepunk did a test the other day, one of their videos, where they did a head swap, and they had it's a big compound turbo setup, and they ran it out to I think like 3,800 RPMs, 3,700 RPMs, and did a head change too. Like I always like stuff that's named in stages. It's a stage 3 head, and this isn't to like demean any of those people that make it. It's a D&J head. It's an awesome head. It made more power, but it made 70 or 75 more horsepower. Average up between that 3,300 to 3,700 range. So I'm like, well, it made more power, but if we go back and do the math to calculate all this stuff out, that's a 4% gain in VE for what was probably 4,000.
Yeah,
a lot of money for 4% gain, and 4% sounds really good. Other than 4% was 70 horse.
Yeah.
Like, you know, we could change the turbo setup on it, or change the injector out, or change the tune, or put more gate. You know, there's other things that could be done to kind of do the same thing. So I was like, not to be rude towards putting a head on something, but you don't have to put the head on it like a lot of places advertise it. You get asked about camshafts all the time, like I need a towing cam, and a spool, like the spool cams and like the biggest drop-in cam, and I'm like, they all do the same thing.
Yeah, Holdener and I go back and forth about the all the cams and all the cylinder heads are the same. If you oversize everything, you're going to get punished. But most of the time, a lot of the stock stuff is fine. And then similarly, where that's where, like I say, not to discount Jose and all those other guys that build class killer turbos, but for the what I always say is the burnouts and ice cream, people don't really give a shit about spending another $2,000 to make 1% more horsepower than their neighbor. $400 turbo is fine for that guy, and a class killer from Jose is fine for the guy that needs 1% on top of the guy next to him. Yeah, so they have different use case scenarios. Like you said, it's not that the head is bad, it's just that most people don't need to touch that at all.
I said, I always kind of look at it, like, if you're not class limited in any way, then that's the way, just increase the boost pressure and stuff like that. But that's really where that stuff comes into its own, is class limited stuff. So if you're limited to this size compressor wheel, you're limited to this size injector or this size turbo or whatnot. Now, like a head and a cam for 70 horse, or 100 horse, 70 horse, or even 40 horse in some of these spots makes sense. And tractor pulling and stuff, people will pay big money just for a different compressor wheel and turbine wheel design that's the same size if it gains, 1.5 to 2%.
Yeah, that's where force performance comes into play on a lot of his stock size replacement turbos that still gain power from like 30, 40, 50, 60 pounds of boost. They just keep going, and it's because of the design and all the testing. And I guess I think he said aerodynamics play a huge part. Like if the aero on that turbo sucks at a high speed, it's just not moving air. Meanwhile, his, with the same size, will continue to move air forever. It'll just keep moving air.
Yep, and even turbos can be kind of like cams and heads, or you can actually, profile-wise, you can give up something at 20 pounds and like 5,000 engine speed to gain compressor efficiency up at 60 pounds and 6,000 RPMs. That trade-off is worthy because we don't spend any time, like a lot of I've heard say, we don't spend any time at 3,000. We spend all of our time up there. So it's kind of the same with the diesel stuff. It's just at a different RPM range, where if you do a head and a cam, don't expect it to spool better and to do all this stuff better. Expect it to pick up some VE percentage.
Yeah, better horsepower per pound, but it might actually slow you down because now the turbo has to work harder to fill the same space because it's larger and your turbo is the same size.
Yeah, well, let's kind of look at the engine. Everything stems from, like how like Darren Morgan says it, like everything stems from whatever the piston in the bore is asking for. So like the piston in the bore asks for something through a set size valve. So if you start screwing with that stuff, you're going to change the VE of the engine. And like I did the same thing with my own truck. I put on a big port, big head, big port, big valve head on mine. And I literally have to run like a full turbo size down to get anything that resembles street drivability of the thing. Like it killed everything under like 2,200 RPMs. And for a lot of people, that's not acceptable.
No, especially when your RPM band is as narrow as a diesel is. You just gave up most of your RPM band. Similar to where people buy a gigantic intake, like the big Holly High Ram, and you street drive it, and you take off your truck intake, and you put a Holly High Ram on, and now it feels gutless below 4,000. Because I did that on the last 3/4 ton that I built. I always wanted to try one, and they gave me one. So I bolted it on the 3/4 ton with the 6 liter, and I'm like, where did the bottom end has just left the room? Bottom end has left the chat. Like it was wild from 4 to 7,000, but it's a 3/4 ton truck. It lost all of its guts below 4, which was just ridiculous. Like that's all you wanted in a 5,500 plus pound truck, is to get out of its own way, out of a stoplight, and it lost that. And I'm like, how does a 6 liter feel like such a dog down low? And that had the big turbo. That had the 80-102, and my drive pressure was below boost pressure, was under 1-to-1, but it made very similar power to the 80-88, which was much smaller, technically speaking, and had more than, it was over 1-to-1. It was like 1.5 to 1. And you would think that eliminating that would be better, and it just didn't seem like it did much at all. Almost nothing.
I was like, it just seems to be. It was. I found out through personal experience that that port velocity, based off of like the valve and the piston and the port shape, was a lot more important than whatever the CFM of the head was for where I wanted to locate how the thing runs. And then, like I said, people, like you said, can really screw it up. In your case, at least you had a bigger turbocharger. When on the diesel stuff, you can they'll put a head and a cam on that helps out at 3,000, 3,300 RPMs, but they have a turbocharger that went into peak torque at 2,100 RPMs.
So they're all out of shape.
Yeah, and it happens a lot more than.
So the turbo's nosediving right when the head wants to breathe, and it's exacerbating, right? Because it wants air and it can't get it, so it's even worse than it was.
Yeah, yeah. It'll make like the head and like a cam could probably usually like a cam might pick up like 20 horse on that setup, and even with a head like a better flowing head, it probably won't do much of anything. Just because the two peak points are so spread apart.
Yeah, they're too far from each. At least the gas motor is more forgiving because you have such a you have double at least the RPM band to fix some of your screw ups. Oh well, I think we're what are we at? 3.5 hours, and I would say we're out of questions, and I'm fairly tired today. And every Sunday I do dyno tuning, so I got to get up for that too. So. I would say if guys in the chat want to throw some stuff down quick, we'll ask it before we say goodbye to everybody.
There was one that was low compression pistons and diesels. Do they just do it to sell ether? Did we go over that one or no?
No.
Okay, so that's surprisingly, I've been asked that more often than not lately. It's something that I've learned quite a long time ago, and then no one's brought it up. I almost forgot about it until someone asked about it the other day, and I was like, oh crap, I know the answer to that one. So since we both understand how heads and camshafts work, a lot of the cylinder fill happens after the piston is on its way back up the bore on the compression stroke, while the intake valve is getting hanged open, because there's so much port velocity and port energy, the bore will still be filling on the piston upstroke, because the pressure front at the top of the piston is less than the pressure front coming through the intake tract.
Huh. So it'll push it back out.
Well, it'll push it back out. If you leave the inlet valve open too long,
too big of a camshaft. Yeah.
Yeah. But if now the other thing that happens though too is if you have a higher compression ratio, we can also see that with a higher compression ratio, the pressure front on the piston is going to occur sooner. And there's only so much cam you can put in these things. So what's another way to make the cam essentially think that it's hanging the intake valve open longer is to take compression ratio or piston height out of the piston. So it takes longer for the pressure front on the piston side to get to the point where it's overcoming the valve.
Oh, okay.
Does that make sense? So we're basically making the intake side of the cam think it's bigger than it is by taking compression ratio out of the engine.
Taking height out, yeah. BK goes... It's also because of cylinder oxygen density, and high compression equals more heat and less air.
Yep. Yeah. It's like, so you can only get so much cam in these things. Like the cam tunnel is only so big, and there's so many things you can do. So one of the ways, once the RPM gets up high enough, that called inertia supercharging, that's what Darren Morgan calls it. But a lot of cylinder fill happens after bottom dead center on the way up. So a high compression ratio is going to overpower the intake valve sooner. If you lower the compression ratio, then we can get more air through the intake valve before the two want to fight each other out without having to do any stuff to the cam. The byproduct of that is they do run like crap until there's any kind of piston speed in the things.
So here's a good one. It says, what do you see as a limit of factory cast blocks, like on a Cummins, when they split the block or rip the heads off?
So talking to, we kind of go over this a little bit, but one of my friends, power-driven diesel, I think it's 2,200 foot-pounds torque on like a 12 valve. So as long as you don't go past 2,200 foot-pounds, you're in good shape on the inline six motors. I think it's 22, it might be 20, I think it's still the same on the column rail, which is the four valve stuff. I think it's all around 2,400 foot-pounds torque. So as long as you don't go over that, you can run pretty high. I mean, the guys at Power Driven, they had an engine called hang a rack, stick wide open. They're not sure if it hung a rack or not, but the thing zinged all the way up, and they had a data logger on it, and they were able to see that they pulled the connecting rod bolts apart at about, I think it was 8,600 RPMs. It was like, so basically you can rev it that high as long as you got good connecting rod bolts.
It's insane. All this is insanity. Yeah, I'm going to be dreaming about all this weird info I learned today. Well, I guess we'll call it for now. Well, oh yeah, well, go ahead.
They always split. They typically, like the inline motors, they tend to always split. From what I've read and what you'll see online, is they always tend to split like the back of the cam tunnel or right below them around the mains.
Is that the thinnest part of the physical block? That's why.
I think so. Yeah, when they start to get the cylinder pressures up real stupid, they always. That's why, like in truck pulling, they run a cable around the nose of the head.
Throw it over.
That way, it throws it out the front of the thing.
That's how you always see a Cummins fail. It's just like a bread loaf falling out of the front end.
It's mainly just, I mean, I'm sure it happened at some point. It's mainly to keep the thing from falling back over on the driver.
Just like Top Fuel, they have the blower straps, so it doesn't throw it into the crowd or something. Yeah.
Yep. Well, did I bore everybody enough for long enough?
Oh yeah, I'm all overwhelmed here. Yeah, so I guess we'll say to everybody, we'll say thanks for joining in, and I'll say thanks for being on the show. I learned a lot. I learned like way more than I was expecting to, which is what I wanted to. So
thank you for having me.
Oh man, yeah, I hope you had fun and everybody else had fun. Yep. So we'll say bye to everybody and then we'll close her down. So see you guys later. Or I think I forget who. I don't think I have anybody. I have a bunch of people who I want to line up that are probably going to be harder. Like I think I had Kyle Loftus, owner of 1320, say maybe. I had Garrett say he would, but that guy's so busy, it's going to be tough, I think, to nail him down one day. And then I'd like to get... See, I have so many people I know that like they all do fab or they all do tuning. I don't want to just inundate 6 tuners in a row. It'll get kind of stale. Tom Nelson said he would do it, so maybe I'll try to get him on Saturday. That would be cool to get him on the hook.
Yeah,
a bunch of people.
He has a blower motor, small cube blower motor. I think that was doing like 800 foot-pounds at like 2,600 or something like that.
Yeah, he's had some really cool stuff. He even did that offshore boat engine where he held it at like 1,000 horsepower for like 60 minutes or something crazy. It just held 1,000 horsepower, and he's done a lot of neat stuff. And he's done like a lot of. I feel like. He just puts up a video of him doing, like, he doesn't do it much anymore. He would put up a video of him doing, like, burnouts and just having fun. So I know he would be, like, a regular guy to have on. Another interesting person, you know who Iraz Motorsports is? Hank Iraz in Las Vegas?
No, I don't.
A lot of the 5-cylinder Audi stuff. He's out of control with that. And that guy said he would do a show. A bunch of really cool people. So I'd like to get them all. Oh, yeah, Miles Kerr. I think his name's Miles Kerr with the Integra. Like I said, a 1,300 plus wheel horsepower 2-ish liter Honda. That's dumb. And then he just made it all-wheel drive now. But yeah,
you have to look up Shane T. I like his stuff.
Yeah,
he's a hardcore tuner, but he's also worked on some pretty crazy. Like I said, that 1.8 liter, they're running like 125 to 130 pounds of boost on it.
That's what people said. Shane T tuning. He's like, I have all these. I'm gonna research Black Sheep, Ragged Edge, and Shane T tuning. Oh yeah, and then Firepunk would be cool to have on, not directly after you, for like I said, stacking too many diesel or whatever people is whatever. But yeah, it's 11:30 here. What is it there? Like 2 hours, 3 hours?
8:32.
Oh yeah, nice.
Dang, my stuff's right.
All right. Well, thanks for tuning in. I said this probably 3 times now. Thanks for everybody for tuning in. I swear I'm going to end it now in 30 seconds. All right. See you later.
Thank you.
Thanks. Yep. Bye.